The Earth is very flat.
What's going on, everybody? It is Monday, March 1st, 2021. Spring is right around the corner, and it's starting to feel like it here for sure. Hope everybody's doing good out there. Let's say hello to everybody in chat. Rude Earther. What's up, Rude Earther? Natural Law Abider. Page 42. No shouting tonight. No promises. Rob Keane. What's up, Rob? Mark Collard. Ian Adams. Flat for Life. Chrissy Heavey. Anthony Burrows. Enigma. And Matrix Media. What's up, guys? Hope everybody's doing good. Tonight, what have we got planned? Per a suggestion from Chrissy last week, I found the 100 Proofs by, what's his name? Oh, shoot. I put myself on the spot with not knowing his name. William Carpenter from 1885. And I thought it might be interesting this week to look through that and see if we still think those are proofs. If there's any out of the 100 that, we haven't talked about or thought of, or just go through them and see what they knew in 1885. I'm not real familiar with who William Carpenter is, so maybe someone out there knows quite a bit about him, but evidently he was a flat earther in the 1880s, and it'll be interesting to see what he said back then compares to the things that we say now. Anyway, let me see here. Streamlabs link. Let me pop that in the chat. If you want to support the show, you can do it through Streamlabs or Super Chat, and the Streamlabs link will be pinned at the top of the chat window for the duration of the show. And then we are trying to get a group on Crypto tab. So if you want to download that browser, it runs in the background and generates cryptocurrency. So it uses your extra CPU space and kind of runs in the background. So there's a referral link for that. A few people have tried it. I haven't gotten any feedback on whether they like it or not, but it's pretty innocuous. Anyway, okay, we've got a few people in chat. Actually, quite a few people in Discord. So why don't we head over there and get things started?
He's a clown, basically. Shout out Travis.
Yeah.
And what's amazing to me that he doesn't even realize the implication of the things that, like, he thinks he's being clever.
Oh yeah,
Yeah.
I just went to his his playlist where he's got all this stuff for me, and I just went through like 3 or 4 different videos before I came in right now, and he's pointing out that my photos have different positions, right? It's like, oh, the tree line is lower here. Oh, the buoy is higher here. And he just doesn't realize that it's the conditions of the medium that changes everything. He just doesn't get it.
I think
Bro,
he does
he's so
actually
stupid.
get it.
He can't
Travis.
read a map.
I think.
Well, but see, the thing is, like,
No, he's actually stupid.
Yeah, but even let's.
You remember the 13-mile bridge thing we did?
Yeah.
He thought I was 6 miles. Now that's a big difference there.
Yeah.
I just don't think they comprehend the multiple variables that there are when you're trying to analyze a photo. They think like it's one thing, like refraction. Like yesterday I was in Jose's talking to Bearded, and like I kept telling him, like, bro, how do you account for the sun and the heat and the temperature? And he was like, what? The sun? Like what? Like he had no idea what I was talking about.
Anyway, let me see. What's up, guys? Good evening. We're live.
Hey, Brandon.
Hey, Brandon. Hey, yeah, mate.
How you guys doing? Let me quickly run through who is in here so people know. Got Aaron A, Bandsaw Bandit, Brian Leakey, Chrissy, Travis, Jimbo, Matrix. We've got Jeremy, although I heard he's going to be in the background. SE Montreal, and the real Bob Dole. Hope everybody's doing good tonight.
Hello, what up?
Hello.
Hey.
Absolutely fantastic on this glorious Tuesday morning.
That's not what this is. This is a Monday evening.
This guy doesn't even know what
Stop.
day it is. What a loser.
Stop
Get
trying
with
to be in the future.
Yeah, stop being such a time bandit,
Oh.
trying to steal our evenings.
Careful, your flux capacitor will fuck up.
So what's new? I heard you guys we're getting pretty heated there about something. What
You know
what
what's
are you guys talking
new?
about?
A new kind of matter that bends the laws of physics. That's what's new, Brandon. Haven't you heard?
No, what's this?
Are you not up on the scientific community? Check this out. Meet the swirlon. The swirlon, a new kind of matter that bends the laws of physics.
The swirl on. Is this a real thing or are you making this up?
This
Somebody else make this up.
It is on Live Science.
Oh.
And it is apparently a real thing. But listen to this. I wanted there's all kinds of ridiculousness, but the guy who apparently is the person who discovered it, or the main guy working on this swirlon thing. Listen to his name. Nikolai Brylyantov. It sounds like the name you give the cartoon character that's the genius kid, so everyone knows he's the smart kid, so they're reminded that he's the smart one on the show.
But also
sounds
foreign.
It sounds so pompous.
That's funny.
Yeah, so apparently, let's see here. Physical laws such as Newton's second law of motion, which states that as a force applied to an object increases, its acceleration increases, and that as the object's mass increases, its acceleration decreases, apply to passive, non-living matter ranging from atoms to planets. But much of the matter in the world is active matter and moves under its own self-directed force, said Nikolai Brylyantov, a mathematician at Skolkovo Institute of Science and Technology in Russia and the University of Leicester in England. Living things as diverse as bacteria, birds, and humans can interact with the forces upon them. There are examples of non-living active matter too, nanoparticles known as Janus particles, and he goes on and talks about that, okay? But now listen to what they did. To explore active matter, Brylyantov and his colleagues used a computer to simulate particles that could self-propel. These particles weren't consciously interacting with the environment, Brylyantov told Live Science. Of course they weren't. Rather, they were more akin to simple bacteria or nanoparticles with internal sources of energy, but without information processing abilities. The first surprise was that this active matter behaves very differently than passive matter. Different states of passive matter. He explains how basically water can change into steam, whatever. The particles, so what happened here is the particles group together as large conglomerates or quasi-particles, which mill together in a circular pattern around a central void, kind of like a swirl of schooling sardines. The researchers dubbed these particle conglomerates swirlons and named the new state of matter they formed as a swirlonic state.
Oh.
Now, so understand this, Nikolai Brylyantov basically ran a program on his computer. That program did something, and they've decided that they've discovered a completely new matter state because of these. And listen what he says. He says, the simulations were basic and experimental work with real-world active matter is an important next step. Their simulations are what they're talking about here. No real science was done. They watched a simulation, and they're saying, actually observing this happen in real life would be the next step in the experiments.
Oh wow, that is really that is something.
That's how backwards they are. That's how messed up in the head. They think they've done science because they ran a computer program, and the next step after that is going to be them actually trying to observe this in real life.
Talk about pseudoscience. So then that this is their whole game of, we predicted that it would be there, and then it was there.
Yeah, well, imagine that.
No, that shit checks out. It's natural science.
Right.
Their ultimate goal is to create self-assembling particles. What?
What the fuck?
What the?
Yeah. No kidding. So anyway, that's apparently what's new in quote unquote science.
The simulations were basic, and experimental work with real-world active matter is an important next step. Wow.
You know, one might claim that real world active matter, like experimental work with that, would be the most important first step. Someone might make that claim, but that person doesn't have a last name as awesome as Brilliantov.
I mean, that's got to be made up, right? I mean, that is like you said, like the cartoon character's name, but they wanted him to be Russian, so they just added OV
Right?
at the end.
Right?
I mean,
This is Frederick Smartmanson.
oh my gosh, these guys, they're just jumping the shark. Brilliantov and his colleagues also plan to do more complex simulation. Oh, good. These will more closely resemble insects and animals and help to reveal the physical laws governing schooling, swarming, and flocking. Oh, this is weird
So their
shit,
computer
man.
program, their simulation, will supposedly reveal things about real life. The thing they watch on their screen that they program to do what they need it to do or want it to do, that's going to somehow tell them something about real life.
Yeah, I mean, that's got to be the definition of pseudoscience, right?
Yeah.
Rob Keene, $5. I would rather trigger a baller with how long can we make a straight line? Yeah, we do that quite a bit, Rob. That's for sure. Wow, that was a good find there, Bob. And that's just from 10 hours ago, too.
Yeah.
Hot off the presses here, folks. Here, I'll put the link in chat so you can see that.
So just keep your ears open. We might be having to deal and field questions and or statements from ballers about swirlons now. That might be a thing that happens.
Well, I mean, you could do natural science inside a simulation. That's fine, right?
Yeah, so swirlons are okay, but ether band, no, you can't do that.
Oh, no, of course not. Don't be ridiculous. You're out of here with that bull crap.
Oh, you haven't put it in a computer program yet, Travis. That's the problem.
That's because I can show it to you in real life. These guys can't. don't need no
So one thing I had
files.
planned to do tonight was I found, well, I didn't find, I looked for it. 100 Proofs the Earth is Not a Globe by William Carpenter. Has anybody ever read that? No?
I have the whole thing, but I've looked through it, yeah.
Yeah. Chrissy Heavey suggested that we might go through it, and, you know, it might be interesting to look through the
that'd be good.
proofs and talk about them and see if we agree with them or if we have anything to add to them. So we don't have to go through all 100 in one night, but we'll go through a few and see what you guys think. Sound good? Yeah, okay.
Yeah.
Sounds good to me.
Let's go.
There you go. There they are.
There we go.
We'll start off with number one. Or should I start from 100 and count down? No, we'll just go with one.
There you go. No, go backwards and reach number one.
You want to go backwards? Okay, we'll go backwards.
Yeah, like the top 100 hits of 2020.
Yeah, there we go. The last ones are probably the more interesting ones. You think he saved the best for last, or did he put the bullshit ones at last? He's like, well, I'll put that 99, 100. I'm not sure about that one. Well, I guess we'll find out.
Well, you got to get
Let me
a hook
get
in
them
it at the
swamped
start,
with nonsense and we'll slide it in.
Right. All right, number 100. The sun. Oh, I'm sharing in the Discord too, by the way, so you can see it if you want to. 100. The sun, as he travels round over the surface of the earth, brings noon to all places on the successive meridians which he crosses. His journey being made in a westerly direction, places east of the sun's position have had their noon, whilst places to the west of the sun's position have still to get it. Therefore, if we travel easterly, we arrive at those parts of the earth where time is more advanced. The watch in our pocket has to be put on, or we may be said to gain time. If, on the other hand, we travel westerly, we arrive at places where it is still morning. The watch has to be put back, and it may be said that we lose time. But if we travel easterly so as to cross the 180th meridian, there is a loss there of a day which will neutralize the gain of a whole circumnavigation. And if we travel westerly and cross the same meridian, this is a long one, we experience the gain of a day, which will compensate for the loss during a complete circumnavigation in that direction. The fact of losing or gaining time in sailing around the world, then, instead of being evidence of the Earth's rotundity, is, as it is imagined to be, is in its practical exemplification an everlasting proof that the Earth is not a globe. Whoa. First of all, yeah, what? What? Huh?
That's a mouthful.
I think we need just a show just to unravel that one.
What is he talking
You got to
about?
start us off with something easy.
Oh, do you guys know what he's saying?
Yeah. Let me
This
try
is
to.
fantastic. I hadn't thought of that before.
All right, go ahead, Bob.
Hey, Bob, can you turn your mic up a
he's
little
right,
bit? Can you
because-
get closer or something? You're just a little low.
Okay, so if I'm understanding correctly, what he's pointing out is the fact that how do you even say this? So the fact that the Earth isn't rotating as a ball like they say it is demonstrated in the fact that you could start at one point and go around, like basically circumnavigate, and the way the time works out, you would get back there and you would either have gained or lost a day. That can't happen if the Earth is a ball that's spinning. You would have lost more or less than a day because of the fact that it was in motion while you were moving. I think that's what he's saying. And that's fantastic.
I'm still not getting it, but Travis, you had a thought? Was it the same as Bob's or something different?
It was different, but I again, this is a pretty profound discussion. But the way that I took it was just simply the fact that if you just travel across the surface of the Earth, you're going to encounter the different phases of the day. I mean, we've talked about this before, that if you, or I've said it in this way, that if you could keep up with the sun and just follow it in its circuit, you know, you would never experience the feeling or the notion that you were traveling over a curved surface. So the way that I heard him explaining this was just simply that this makes sense as you're simply traveling along and over a flat extended plane. You're just simply going to come across the different positions of the sun, and there's no issue with it. Of course, you're like, if the sun is above you at noon, and then you start traveling east so that you're traveling in the opposite direction, right? Then it can be said that you're going to be going back in time because it's going to be darker in that direction. But if you move west and you overtake the sun, then you're going to be gaining. I don't know if that makes any sense. That's what I thought of.
Guys, think about it this way. Think about if you're on the equator and you're spinning at 1,000 miles per hour like they claim, okay? In 24 hours, you make one full rotation. That's a day, right? You with me?
Yep.
Yeah.
Okay. If the Earth is we'll just keep going with an Earth that's spinning. If it's spinning at 1,000 miles an hour, okay, you're standing there, you're moving 1,000 miles an hour. If you begin to move along the Earth at 1,000 miles per hour, and the Earth is spinning at 1,000 miles, you're actually you should be covering 2,000 miles worth of distance as you're moving, because it's moving 1,000 miles spin. You're moving 1,000 miles per hour along it. You should gain more time that way than if it's flat, if it's just stationary.
Yeah. Right.
And
right.
you should lose more if it's just
Right.
than if it is stationary.
Yeah,
And I
but
think
this,
that's what he's pointing out, is that it can't be moving because the time lines up with it not moving. The amount you gain or
Right.
lose lines up exactly with it being stationary. It doesn't match with it being a moving thing.
right. So you know that it's moving because you can't tell that it's moving.
That's what they would say.
That's
Yeah.
That's what they would say.
right.
But this,
But
I hadn't thought of the time aspect of it. If you're moving it, if you move 1,000 miles per hour across the equator, and it's also spinning at 1,000 miles per hour, you should be able to get around way faster, and basically the time should be cut.
No, because
by a connected amount.
but it's all relative to, this is what they say, okay? It's all relative to the Earth rotating. So you're on the Earth, you and the Earth are going at 1,000 miles an hour to the east, right? So
right,
if you start moving in 1,000 miles an hour to the east, you're only going 1,000 miles an hour in relation to the Earth. You're going
exactly
from the viewpoint of, let's say you were stationary looking down at the Earth. From that vantage point, yes, you'd be going 2,000 miles an hour, but in relation to the Earth, you'd be going 1,000 miles an hour.
Right. So you would have moved 1,000 miles, but the place that you end up at would have also moved 1,000 miles for 2,000 total miles. That doesn't happen.
What I'm trying to say is they've devised it in such a way that the Earth, the rotating Earth, behaves exactly as it would on a flat plane. That's how they've devised their model.
that's what I was trying to say. Yeah.
Yeah.
You don't get to claim that you're conserving all the momentum no matter where you are, and then simultaneously claim that the conservation of momentum doesn't affect anything that you're doing. You don't get to make both of those claims at the same time. Either the conservation of momentum is there, or it's not.
I agree with that. Yeah. But Bandsaw, what'd you say?
I'll just say, I don't think what Bob is saying there, it's not as clear as what he's making it out, what is written there, what he's explaining. I don't think it's that clear. All he's basically saying is if you either catch up with the sun or you're behind the sun, your day's like longer or shorter, or you're gaining a day. He's just talking about time. Really, I can't see where the rotation is really coming into it.
What matters is how much time you allegedly gain or lose. You don't actually gain or lose any time. That's not how time works, okay? We all understand that, right? You can't gain or lose time.
Exactly.
It's just us making markers. His point, though, isn't really actual gain and loss of time. It is saying that the markers would indicate a gain or loss of time, and that gain or loss is consistent with a stationary Earth, not a rotating Earth.
Yeah, so you got to think back. This was written in 1885. I don't know how advanced their model was at that time, because relativity wasn't even born, right? So would they have said, if you talked to a Glober back then and said, well, how come I, when I fly in a plane and go east, why can I travel so much faster, and why don't I get to my destination shorter when I go west? That whole thing. We know what the answer is today, what they would tell us. I wonder how developed that answer was back then. That's going to be the difficult part of this is, we're kind of taking ourselves back in time like 140 years.
Hey, would you mind reading it again now that we've kind of talked about it? See if it snaps something into place for somebody reading it a second time.
Yeah, good idea. Okay. I wanted to mention one other thing that I thought was strange. It was in the first couple sentences. He refers to the sun as a male with male pronouns.
Yeah, because the sun is male and the moon is female.
But that's not typically done these days, is it? We always refer to the sun as it.
Haven't you ever heard Owen Benjamin talk about the moon? And it's, what is it? It's Luna instead of something else, Luna. It's supposed to be a female.
No. I
Have
guess
you
I haven't
guys heard of
that.
Helios, the sun god? Sorry, Brandon.
Oh no, go ahead, Essie.
You guys, of course, heard of
La
Helios,
Luna.
the sun god? Was a male figure back when.
Okay.
There's a Disney Junior cartoon called PJ Masks, and there's like this one of the evil little kids is a female, and she's a lunar moon something. I don't know. I forgot.
I think
Somehow they made her female with the Statue of Liberty.
I
But
think
that
in
somebody holding that flame came from back then, from Helios. They had a great big statue in Rhodes, I believe, in the harbor.
Yeah,
Disney
it's also
Juniors.
with Apollo, Helios and Apollo.
I think I might have said
Yeah,
it wrong.
yeah.
In Spanish, it's La Luna because it's supposed to be female instead of Le Luna. I think that's what it is.
Just real quick, since we're talking about the male and female counterpart, Crow 777 associates roosters with the sun because the energy and electricity that happens in the or in the sky, and I think that has to do a lot with the electromagnetic field. The roosters are in tune with what's happening. They know morning is coming, but it's the male identification of the rooster with the sun. So it's just, again, yeah, if you look back into mythology, if you look back into astronomy, the sun is masculine and the male is, or the moon is feminine. That's the yin and the yang.
Yeah, also referred to as Prometheus. Remember that, Prometheus? Yeah.
I never associated Prometheus with this discussion. What do you mean?
Well, Chad just typed it. Didn't
Yeah.
Prometheus fly close to the sun? Wasn't that the story and got burned, or
Well, yeah.
am I thinking something else?
Prometheus created for himself the ability to fly by constructing wings that would work on him, and he sealed them with wax. And he flew to get close to the sky, and when he got too close, it was too hot, so the wax melted, and he fell to his death. So
That's it.
But I
It's
don't.
supposed to be Icarus, right?
Is that Icarus?
Yeah.
I get them
That's
mixed up,
Icarus.
man. I'm bad at this.
That's
Well,
it.
Well,
That's
Prometheus
ridiculous,
brought
man.
the flame to man,
Yeah. Icarus.
That's
and I
right,
thought
yeah,
that's
yeah.
what I was.
Yeah.
I might have got it wrong, but I thought that's what the Statue of Liberty is holding. She's holding the flame. So I might have got that mixed up.
No, it
Well,
said-
the
I'm
whole
looking
thing
it up. Greek mythology. Prometheus is a Titan god of fire.
Yeah, he's the one who got punished and tied to a rock and had his eyeballs picked out for all eternity. You're right, Icarus, Bob. That's right, Bob. Icarus was the one that flew too close to the sun. But just to
And
go,
Helios for sure is the sun god. That I know for sure.
yeah, and just to go back to what Essie pointed out, that if we look at channels that deal with alternative histories, the Statue of Liberty is not feminine. Statue of Liberty is masculine. It is a male god. It is Apollos.
Huh?
Yep, yep.
That's one good-looking
That's a
dude.
fact. Yeah. They dragged them. Hey, they drag queened them.
Well, this is the
from
thing,
back
you
then,
mentioned-
bro.
You mentioned drag queening, so if you go back to ancient priestesses, what you would have is you would have male priestesses. So they would have long hair, they would eunuch themselves, they would take away their testicles. So you would have transgender priestesses. So this is what some people say that the Statue of Liberty is. It's a male priestess.
Oh, that's interesting.
Nicely done, Jedi. Like the
Good evening.
eunuchs.
Yeah.
Good evening.
All right, let me read it one more time, see if anything jogs in anybody's head, and then I will we'll move on to the next one. All right. The sun, as he travels round over the surface of the earth, brings noon to all places on the successive meridians which he crosses. His journey being made in a westerly direction, places east of the sun's position have had their noon, whilst places to the west of the sun's position have still to get it. Therefore, if we travel easterly, we arrive at those parts of the earth where time is more advanced. The watch in our pocket has to be put on, or we may be said to gain time. If, on the other hand, we travel westerly, we arrive at places where it is still morning. the watch has to be put back, and it may be said that we lose time. But if we travel easterly so as to cross the 180th meridian, there is a loss there of a day, which will neutralize the gain of a whole circumnavigation. And
Stop there, please.
okay.
So what I understand that to be is the 180th meridian is the termination of day and night. Is that what everybody else understands that to mean?
No. I thought that was like the international date line or something. I don't know.
Well, the international
Isn't
date,
that the line that runs through London, through England somewhere?
I don't know, but the international date line, as far as I understand it, is that line that runs down the Pacific, right? But 180 is half of a circle.
I might have a good way to explain it. Okay.
All
If you were able to go around the entire Earth in 1 hour, okay, on a stationary Earth, you go around the entire Earth in 1 hour, you've only lost an hour because you went right back to where you were. Does that make sense?
Yeah.
You only lost an hour in your travel because you traveled for 1 hour and you're right back to where you were. You only lost your hour because you're right back where you were. If you're on a ball, it rotated for 1 hour and you went around it for 1 hour, you should lose 2 hours.
Okay, I get that, but let's not miss the 180th meridian just real quick. I saw you pull that up, Brandon.
Yeah. So the 180th meridian is the meridian both 180 degrees both east and west of the prime meridian, with which it forms a great circle dividing the Earth into western and eastern hemispheres. No, it doesn't. It is common to both east longitude and west longitude. It mostly passes through the open waters of the Pacific, but passes across land in Russia, Fiji, and Antarctica. It is used as the basis for the international date line, but the latter deviates from it to maintain date consistency within the territories of Russia, the U.S., Fiji, and New Zealand.
All right, so I'm sorry, but I'm kind of getting my memory tweaked here. There was a channel that discussed the what's the word I'm looking for? The discrepancies at the Bering Strait, right? The Bering Strait is that section between Alaska and Russia.
Right.
And there are 4 time zones within that small little narrow part. And the discrepancies between time is so great that they are saying, this channel, I can't remember if it was APV, it might have been APV, but the discrepancies there are like, there's no way. It's like saying that there are 4 time zones between Texas and Oklahoma, right? The space is so small. How can you have 4 different time zones, like 4 different noons? But the channel was saying that distance is not accurate because you have it has to be more massive and more distant than. But the other thing about the prime meridian and the date line, like you mentioned, is there is no commercial or personal travel through that area ever.
No commercial or no travel through that area ever, you
Nope.
said?
Nope. That's like another Antarctic Treaty thing. You cannot go that direction.
Oh yeah, it's all fucked up. The time zones are all fucked up right there. You can see it on my screen. It's like they're all jagged and screwed up. I remember seeing some of that too, and I never really looked into it. It'd be interesting to see a detailed breakdown on what's going on around here. It might just have to do with convenience for the people who live in the area and islands being in the same time zone and shit, but who knows? It may also be the construction that kind of hides the fact that there's a lot more space in there, as you were alluding to. They'd have to do something like that. It's got to be screwed up somewhere, right? At least I think it does, in order for the mapping to work out correctly, but maybe not. Anyway. Okay, so I'm not too hot on this one, to be honest with you. This proof here, but I'll keep going. And if we travel westerly and cross the same meridian, we experience the gain of a day, which will compensate for the loss during a complete circumnavigation in that direction. The fact of losing or gaining time in sailing around the world, then, instead of being evidence of the Earth's rotundity, as it is imagined to be, is in its practical exemplification an everlasting proof that the Earth is not a globe. I don't understand this one still after all that discussion. But if anybody got anything out of that, speak now or forever hold your peace.
Yeah, we can move on, but I think that Bob has got the sense of what was being said.
Yeah. Okay.
Yeah, that one's as clear as mud.
Right. Yeah. That's kind of how I feel too.
No, the way they do it with a 24-hour clock on a flat Earth, the sun is your clock. Okay, on a globe they got all these time zones and shit. So we wouldn't know much about it because they didn't hardly tell us nothing about the sun being a clock. We had to learn that through flat Earth. That's what they're talking about, man. The time zones don't add up. They don't make sense. On a flat Earth, the sun is your clock. Bam.
So that goes back to what you were saying, Brandon, about the relativity issue that wasn't around in the late 1800s when this book was written. My question, since Brian said what he said just now, is that when were time zones established to start to screw with our ability to be in sync with nature? Because again, the sun is our hourly clock, the moon is our monthly clock, and the zodiac is our yearly clock. But they have completely basically divorced us from nature by putting in time zones and daylight savings time and all this other shit.
Oh, and it's the prime meridian that runs through the Royal Observatory. I mixed it up with the other one. My bad.
Yeah, no worries.
1884, like just before this was published, is when they formally kind of adopted the time zones. So interesting.
Maybe that's high up in the list.
So
They try to say that the AE map or the Gleason's map is the top-down projection of a globe, and it is most certainly not, because if you look at down projection, if you go to one of the map apps and you look at the southern projection, with the South Pole being the North Pole, you could see if it's a globe, it should reverse perfectly, right? No, it doesn't. It doesn't look nothing like an upside-down Gleason's map. They're full of shit. It's not a top-down view of a globe. It's more accurate than the globe, but there's still distortions. Thank you.
Huh. Okay. Chrissy had a good point. She's saying that we probably should start at number 1 because some of them build on top of each other, and it might be confusing. So why don't we go back to number 1? I'm a little burned by my experience with number 100 so far.
I meant to say that's why it's so far down in the list.
Hey, I'm really happy with number 100. That's good stuff as far as I'm concerned.
Well, that's something to look forward to then, Bob. We got what other gems are down there? All right, number 1. The aeronaut can see for himself that Earth is a plane. The appearance presented to him, even at the highest elevation he has ever attained, is that of a concave surface. This being exactly what is to be expected of a surface that is truly level, since it is the nature of level surfaces to appear to rise to a level with the eye of the observer. This is ocular demonstration and proof that Earth is not a globe.
One word. Picard.
Aeronaut. See, that shows you like Picard had names for that, so he wasn't the only one. And that's why I said if they put people up there in capsules, why couldn't they have stations or platforms or some shit up there, They had it back in the late 1800s, man. Ain't no telling what they got up there now.
Yeah, but what did Picard say when he went up?
Looked like a flat disc with upturned edges.
Exactly.
Yeah, this was way before Picard, too. Picard didn't say that until like the 20s or 30s, I believe.
Yeah, he saw it. He actually saw it. Well, that's the story, right? If we're to believe it.
Yeah, but this is 1885. This guy's talking about aeronauts seeing concave surface, which is what Picard described. And this is like 50 years before Picard.
I know, yeah. Point well taken. Yeah, for sure.
Yeah. One thing
Dude,
that
we've probably always known hot air rises, so they probably had, aeronauts, air vehicles. I mean, it's the first people who've seen smoke going up off the fire. I mean, I
To
think
them, he probably.
they don't give enough credit to our ancients, to our forefathers, man. Before, they make it seem like written history. Like something could have happened where we lost a lot of written history. I think we all consider that.
To him, an aeronaut could have been a hot air balloonist. That's all.
Yeah, looks like that was a popular term back in the day for sure.
Also, I'm pretty sure they split water. I mean, not split water, but they performed electrolysis on water like way back when. I think it's like the late 1700s or early 1800s. They made hydrogen way back when.
But think about the change in terminology. An aeronaut is someone who sails through the atmosphere, the air, and then they had to stretch that out farther to astronaut, to someone who goes into where the stars are.
Yeah, that is interesting. The one point of contention is that let me see here. He says the appearance presented to even at the highest elevation he has ever attained is that of a concave surface. Level surfaces to appear to rise to a level with the eye of the observer. So he doesn't say that the horizon always rises to eye level. He just says it's the nature of level surfaces to appear to rise to a level with the eye of the observer. I think this is worded pretty well.
Yeah. He like deduced it before it happened.
Yeah.
Well, if we were to believe Picard, that is, eh? Yeah.
Right. Yeah, if we can believe his story. But how high were they getting up in 1885? We need more information about ballooning in the 1800s. It keeps coming up.
Oh, he went up pretty high. He was in a pressurized steel thing. I don't remember how high it was, but it was pretty high.
Yeah, but balloons, that was 1800s. That was the Montgolfier brothers, the French people, not Picard, which was about 100 and 150 years later. Picard got to 75,000 feet in his pressurized container. We're talking about Montgolfier and the first ballooning. As high as you can get, really? 2,000-3,000 feet, I would have thought maximum. Especially for when they first started going up. And we're talking about, again, Montgolfier, the French brothers. So 150 years ago. So 2,000-3,000 feet. Good conditions, maybe 3, 4, 5. Depends where you are.
Yeah, back
But
then,
not
yeah, for
high.
sure. Yeah.
But not high. Not like 75,000 feet like Picard got to in like 29 or 31, whatever it was.
Right, yeah. Yeah, they weren't getting that high.
So he got to 75,000 feet, you say, Picard?
Picard, yeah, 75,000 feet.
Nice, yeah. I know he got pretty high, yeah.
That's high enough to see a lot. That's almost like 2 times as high as a commercial jet goes. Let's go on to number 2. Whenever experiments...
an F-15 goes to... Sorry, one thing. An F-15 goes up to 60,000 feet, so...
Oh, okay. All right. Number 2. Whenever experiments have been tried on the surface of standing water, this surface has always been found to be level. If the Earth were a globe, the surface of all standing water would be convex. This is an experimental proof that Earth is not a globe. Now, this is interesting because I wonder what experiments he's talking about. Were there experiments that were going on back then to try to figure out the shape of the surface of water?
Yeah, obviously there were, and they're suppressed. Obviously, the only one we hear about is the Bedford level, because it made it into the legal system. So obviously they suppressed other experiments, unless he's just making shit up.
That term is misleading because it wouldn't be an experiment; it would be a test.
Well, right, but that goes back to all the nomenclature back in the day, right? For them, that's what a test was. It was an experiment.
Fair enough.
Right.
What's also interesting is that when that was written, level meant level. It didn't mean curved and bending, and that we hadn't redefined, the meanings of words in our syntax just to suit the story we're trying to sell.
The good old
level
days.
was level, like we all colloquially know level is level. shall I say level is level another couple of times?
Sure.
When they bring in experiments, man, I mean, I don't know. When I say experiments, like I don't naturally mean like scientific experiments. I think it's when they claim science and scientific experiments is when it takes a stricter meaning. In my opinion, we could call them tests, experiments, but if we want to claim science, then it falls under more strict criteria.
Yeah, you're right. I mean, casually, it is. You can think of it as they're experimenting with these devices, and seeing what it produces. So yeah, I agree. There's like a colloquial definition and then a strict science cause and effect type thing.
All right, number 3. Surveyors' operations in the construction of railroads, tunnels, or canals are conducted without the slightest allowance being made for curvature, although it is taught that this so-called allowance is absolutely necessary. This is cutting proof the Earth is not a globe.
It'd be harder to even take care of the movement, much less the curvature. We can appreciate it might be locally flat, but like the fact that they don't take into account the movement, like if you have a building, like one side of a building is experiencing a different way, just a different like a different journey and all that kind of stuff. Like that part would be more obvious how they would account for that. If it was
I've done enough local surveying, man. I've done enough local surveying, and I've heard enough planar survey that all the state and all the old surveys, they're not accounting for earth curve. They're accounting for elevation changes. If they want to go back and add earth curve, they can do that. And then they've even found a way to look long distance. I think they're using the bending of light, in my personal opinion. But when you do all these, in my opinion, they're spitting in the face of our forefathers who went across country and statewide closing loops to measure elevation changes to just later on call it a globe and add corrections to their measurements. What is that?
Yeah. This one is still one that flat earthers mention pretty much all the time. Number 4, there are rivers that flow for hundreds of miles towards the level of the sea without falling more than a few feet. Notably the Nile, which in 1,000 miles falls but a foot. A level expanse of this extent is quite incompatible with the idea of the Earth's convexity. It is therefore reasonable proof that Earth is not a globe.
Yeah, that makes sense. Water would never sit still on a ball. It would constantly it would be obsessed about finding a new place. So
yeah, like off the ball.
Yeah, that too. But let's say gravity worked, right? To the center. Like laterally it would constantly want to do what we know that it does. But I mean that's obvious to people here.
And how does it flow the Nile? This is one of my favorites. How does it flow the Nile up the ball and into the Mediterranean?
Well, they would say that there is no up, right?
Yeah.
Right. Yeah, one of the beauties of their model
is.
What was I gonna say? Shit.
Hey, Jeremy, hon, you might want to realize that you're hot micing and I can hear your babies. Hi, sweetheart.
My bad.
You're all good. They sound like they're happy.
We thought that was rumpus.
Right?
Yeah, I don't know. I don't know about
thing...
this one. They can explain this one away with their model, but obviously I'm trying to imagine how it would be different if it were on a globe. Well, first of all the fucking water would boil off into the vacuum that surrounds the Earth, but
then there's that, yeah.
Whatever is happening in the water in the vacuum, we're supposed to be in a vacuum. So whatever happens with the water in it, that should be happening.
That's what I'm saying. Is there a way that they can provide a demonstration of water being in a vacuum that it doesn't boil off or, it just sits there? Can they demonstrate any of this shit?
Nope, that's impossible.
Negative.
Sorry, guys. Can somebody remind me what happens to ice in a vacuum? What happens to that?
It will evaporate too, freeze drying.
Awesome stuff. So if we have, say, rings of Saturn that are made of ice and they're in a vacuum, when they have sublimated and disappeared.
Yes,
No, the
they
rings
will.
of Saturn. The rings of Saturn, they check out.
What, the
Are
ice?
we talking
Yeah,
about
yeah,
the same
yeah.
guys that can't
Yeah,
provide
I've been there. They're for real, definitely.
Jeremy.
Well, don't forget the diamonds, eh?
Yeah. Sorry,
Mm,
somebody
beautiful
mentioned
Jupiter.
vacuum. Somebody mentioned vacuum and the stuff that happens in it. So water, yeah, of course, but ice too. Remember, that's supposed to be ice out there. That shouldn't even exist because when we put ice in a vacuum, it sublimates, correct? So problems everywhere in that place.
I don't know. We had trouble with the water in a vacuum Friday. Let's not get crazy now.
So there's an interesting answer from chat. Oh my God, the water is on Earth under the weight of the atmosphere. Why would it ever boil? How the fuck did the atmosphere? Why does the atmosphere stay there? I mean,
what happens to gas in a vacuum?
oh.
But that's, well, I don't understand why we're even talking about things in a vacuum. The whole point is the vacuum. There's nothing in there, so what? It's like it's not a vacuum anymore. I don't understand the whole. What's the point?
You don't understand.
Can you hear me?
Like, what's the point of even thinking about that?
Well, that's what they tell us. That's the model, right? Mind of God.
Yeah, no, I understand that, but it's I don't know. It's not. It's no longer. Is it not technically a non-vacuum at that point?
Just
or
because
I
the
don't know.
retard exists doesn't mean you have to engage with the retard, right?
Well, no. I think I get your point, but let's say then would you say that nothing can be in a vacuum chamber then? Let's say I create a vacuum chamber and suck all the air out. Is the glass of water inside the vacuum chamber? Is it in a vacuum or is it not a vacuum?
Yeah, exactly. Yeah, that's what I'm getting at. But I guess if we can think of something close to a vacuum, let's say, and you put like an ice thing in there, I mean, I'm assuming it would just disband, you know, like it would have no reason to stay quote unquote together. So, and probably pretty fast.
Yeah,
right?
that's what I think. I just can't understand
Yeah.
why the
We
Earth
made
would
up-
be different. But
The problem
somebody
is we
knows.
can't make a vacuum without a barrier, right? So
Yeah,
so it's
exactly.
pretty hard. It's
That's
pretty
why-
hard to test out.
That's why Gleam made an excellent. Was that Gleam? He made an excellent point when he said, "What about Saturn's ice rings? If they're in a vacuum,
was
there's no
Jedi.
atmosphere to fall back on."
Yeah,
Who said
yeah, I
that?
agree.
Who said
That's
the
the
ice
only-
ring, Saturn?
That's the only place we could bring
Jet-
something that is close to a vacuum.
Oh, my bad, Jedi.
You
Is
got
that far
freeze
away.
drying. You know, you put an ice cube in a vacuum, it'll suck it dry.
Uh-huh.
You know, even
That's a good
here,
answer.
if you go out in the morning and you look at this canal here,
Mhm.
it can be freezing. It's all ice, and you see evaporation.
That's a good answer. Thank you, mate.
Hmm.
You know, why aren't Saturn's rings fucking sublimating?
All right, let's
Because they're not what they're claimed to be.
I bet you they have some crazy excuse.
How does
Refraction, dude. Chill
gas
out, man. It's
congeal?
just refraction.
go.
Relax, dude.
How does gas congeal into a solid in a vacuum? How can
Um,
a
I wanna-
sun be hydrogen gas and be sticking together in a vacuum? There's no coherent sense in that.
There's no coherent sense in the whole fucking thing.
They're gonna land spaceships on gas planets? Really? How do you land on gas?
How do you impact gas? All right, we've all seen the comet that split apart into several pieces, and then Jupiter span round, and we saw the impact of the solid on the gas. All right.
Well, we saw a show from the CGI Masters there again. I mean, what were we really looking at? The Hubble thing there with the
Yeah,
that
Jupiter looked the same.
crashing into
yeah,
Mars whole thing there? Wow.
Pardon me,
You know,
but Jupiter
today
looked
we
the same.
know everything's damn CGI. Almost everything is fake news. Like I say, you want to see a history of fake news. You and people making, well, real news, but with, British intelligence. You look at that group that's called Pathé Films. They're right there for assassinations, for airship blimps, all of these, recorded historical cultural events. These people were there with close-up shots of assassinations and everything. Why? Because they were media, they were spies, and they organized this stuff. They still do it today. In Montreal, when they had the power failure, the big ice storm, the spokesperson for the hydro company was named Madame la Lumière, which means Mrs. the Light. Oh, what a coincidence. Those things
It's
aren't
If you look at
accidents.
Jupiter, one thing, if you look at Jupiter and you see the Jupiter you see that got the impact, it's the same damn Jupiter as one of the passing satellites it got like 5 years before that. Ain't nothing damn changed.
Isn't that the same kind of image of Jupiter when we see the aurora? So there's two images of Jupiter that I know. One is Jupiter, there it is, Jupiter. And then another one is Jupiter with an aurora over the North Pole, the circular kind of a luminous kind of neon blue. And it's exactly the same Jupiter. The storms haven't changed. There's no difference in any cloud patterns. But this is supposed to be 5x amount of years, pull a number out your ass apart.
This is the same Jupiter with the rings and rock belts around it, right? Millions of rocks orbiting this so-called planet.
What are y'all debunking? Planet?
Are one. Well, how do they all maintain orbit and equidistance from each other and pull from gravity from just
refraction?
Don't we need to upgrade it to a 400-year storm now? Ain't it been another 100 years since they've been calling it the 300-year storm? So now it should be the 400-year storm, right?
Yeah.
Saturn
seemed to be the 500-year storm.
Saturn's been debunked.
What are y'all debunking the planets?
Well, if you look at Saturn and through your camera or through a telescope, it doesn't look nothing like what they show it. So it looks like a twisted light bulb, man. It looks weird, man. It's glowy, glow in the dark, man. It's hard to believe that that's the reflection of the sun, making it brighter than. I don't know. I don't know.
No, I agree with you. They look like light bulbs. I agree. They look like they have their own life, their own light.
Especially Saturn.
Yeah.
You look at them through a telescope and they look like planets.
If by planet you mean little circle things, yeah, they look like circles.
They look. Yeah.
Okay.
Yeah, those figures.
But don't you, when you look at the moon sometimes, Howard, does it look like it is glowing, like it has its own light to you? Does it just look like that?
No, I've never considered, as I'm looking at it, that it would be producing its own light. It's just understood that it's reflecting sunlight.
That's the story that they told. Yeah. But what I'm asking you is what it looks like to you.
It looks like the moon, and it looks just like the sunlight reflecting off the moon to me. The sun there, and the moon.
Howard, if you'd never been to school, Howard, and you looked at the sky and you saw the moon, you would just assume the moon is a light. It's only the school education you had when you were a kid where they told you it was reflecting the sunlight, correct? Because everything else in the sky, everything except the moon, is assumed to be its own light source. But at school, when you were a little kid, they told you, no, the moon's not. It reflects light.
I don't recall ever being told that the moon reflects sunlight. As far as that specifically being said,
we haven't been taught that because it's retarded. That's why, because they know it's stupid. Like they don't even
Hey,
want to.
why do you say it's stupid? The sun is over there. We know it shines on us, and the moon's over there, and the sun's shining on it. Why would that be stupid to say it's reflecting sunlight?
Well, the problem with the sun reflecting or the moon reflecting sunlight is that when it's like 180 degrees behind the ball, diametrically opposed, like polar opposition there, the other side of the world, on the opposite path, then how is the sun shining on it when it's full?
Or it's the daytime full moon. The daytime full moon, it can't be the sun shining on the face of it when it's daytime and a full moon.
It's orbiting. its orbit is like 5 degrees off of Earth's ecliptic, and
Yeah,
with the
that's
distance that it is, it's what allows that to happen.
so.
Well,
Have you ever
what to
seen a
happen? Wait,
Sorry.
explain what you just said, dude. That's stupid. What are you talking about?
The moon is not necessarily behind the Earth when it's opposite the sun, because of its orbit is like 5
That's
degrees off.
nonsense.
Okay.
Look, this is
You
this
know,
is the
you
model
put it
though,
right
right?
behind the ball
Hey
and
guys,
and
wait,
on the
wait.
opposite side of the
Guys,
ball.
listen.
You can't see the light.
If he's saying
Okay,
what
so
I
you
think
tell
he's
me what's
saying,
going on. Tell me
guys,
what's going on then.
if he's saying what I think he's saying, he's technically right on that particular
Yes.
point. Okay? And I think we've had this discussion before. That particular thing that they claim does make sense in their model. That's like one of the few things that actually would make sense. The moon could technically be far enough away from the Earth to look to us to be on the opposite side, but also be able to catch the sunlight on its full face. That could happen. You can draw a picture and make that happen. It's really easy
I
because of how
don't
big the sun
think
is.
so.
No, you can't. That's
According to them.
stupid, dude.
That's nonsense.
So the rays,
and I
the
think
rays
Yeah,
zap the
because if
moon.
the
draw
moon
a
goes
picture
right
for
over
us.
our head,
Guys,
okay,
you
if the
can
moon
draw
goes
a
right
picture
over
and
our
make it
head
happen.
and the
Why
He's
don't
sun
you
saying
just
draw
went
us
it's
a
right
stupid,
over our
picture
head.
there?
but he's right.
That's
He is
stupid.
I see
right.
what
No,
you're
he's
saying
not.
on paper, but in real life, when the moon is coming up over our head and the sun just passed right up over our head, I live pretty close to the Tropic of Capricorn, right by it actually. And if
But
they're
listen,
both
we're not
coming
talking about
directly
real
over
life.
me, if they're both, yeah, I know, right? But if they're both coming right over me, then they're not off on an ecliptic. And I heard that the moon varies up to like 3 degrees a maximum ecliptic, which wouldn't be enough for it to wrap around. There's not enough for it to be a daytime and a full moon at the same time, man. In my opinion, they have to
Okay, there
explain
is,
that
but
one
if
away.
we're talking about real life, we wouldn't be talking about the moon being in space or reflecting sunlight at all. We'd just be talking about real life. What I'm saying is,
Good
in
point.
their model, technically it can work. That's the only thing I'm saying does make sense. Like inside their model, yes, technically you can make that happen. So don't argue that. Argue something better.
No, we're saying even in the model, that's absurd.
No, in
So,
their model,
no.
it's not absurd.
Yes, it
Let
is.
me
Their whole
show you.
model. If their model's absurd, how can one element of it not be absurd?
Yeah, and screw their vindicating their
Yes, go with
model. You're
that.
not
Argue that,
justified. It
please.
does
Thank you.
not. It does not match even in their model. Thank
It's
No.
you.
simple. It's
You
simple
can't say,
geometry.
oh, they're justified. You have to find something else to debunk the lit
It's
moon.
Listen, if you're
Bullshit.
going to
I'm
focus on
calling
that one
total
point of your
bullshit.
argument, you're not going to get anywhere with anyone who's thinking logically.
That's
You
full of
need to
shit.
argue a different point. That's
When
a
the
bad
moon
point.
is diametrically opposite, polarly opposite, on opposite
Prove
faces
it.
of the Earth, and
Prove
the one ball is
Prove
on
it.
one side.
Prove
with
that
like,
it is. Prove
like
that it's exactly
Orion
what you just said
belt.
it was.
Prove it, my ass.
Yeah, exactly. You can't.
You're seeing through a fucking wall. Yeah, you got
You
light going
can't.
through walls with your
can't prove that it's
ball
there,
and your
can you?
model. I call
Well, let's-
bullshit on that.
Sorry, Jimbo. Let's
You
look at the
can't
model.
prove that it's there.
No.
So the
but we
rays,
can
so the
All you
rays
can
are
do
the
is
rays.
claim that it's there, right?
The rays are reaching the moon, but not anything around it. That's what you expect us to believe in their model, or not in their model.
There's nothing around it in their model. It's out in space.
Yeah, but if it's
in their model.
daytime, how can the sun be 180 degrees opposed at apogee?
You
at
can't
perigee?
prove that it is 180 degrees.
Well, if it's a full moon and we're seeing daylight, it's got to be at least a slight bit of an angle to be coming around the Earth. So we'd get, at the very least, a 3/4 moon. You know what I'm saying?
Wait, let me handle this. If there, you understand that it's reflecting, so there's line of sight, right? You're saying with that angular thing that there's some way that the sun rays can get to the moon even if it's on the other side, right? So, and then you also said
No,
fair
I'm
point.
not saying that.
Oh, so
What I'm saying is
how's
that
light
the
getting to
moon
it?
looking like it's on the other side of the Earth doesn't mean it's on the other side of the Earth in their model. And if that's the point you're going to argue, you're not going to get anywhere. I know their model is stupid,
Yeah.
but if you're going to try and argue inside their model, you're not going to get anywhere. So stop it.
Yeah, that's fine. But I'm not arguing with you, but just in general, like how we would discuss this. So don't take their side. Don't feel like you have to defend their point is what I'm trying to say.
No, I'm not. I'm not defending their point.
No,
All
I
I'm
don't think he
saying
is either.
That's not where you should be spending your energy, because that particular part of it, if you're going to step inside their model, that particular part does make sense inside their model. You're already in pretend land. So
No, let's step in there.
One thing.
Let's step inside there's model. There's still clouds and stuff in between the moon and the earth, right? There's still things happening. You can say that the moon is very far away. Fair enough. That's fine. But there's still things that would have to be in the line of sight between the sun and the moon, right? They're not being illuminated or reflecting or whatever. So you need to have line of sight. Fine. They can say it's 5 degree, whatever. So I am in their model, dude. Don't worry. I'm not cheating or whatever. It's the whole thing's stupid, man. It's ridiculous. Like,
okay, here. I'll get on the computer in just a little bit, and I'll show you how it can work just fine on their model. Just so I can explain it. And I'm gonna state this. I am not saying their model makes any sense, and I'm not saying it's good or that I believe it or anything like that. It is retarded. 100%. I'm just saying this one particular point is not where people should be spending their energy. It's a bad argument to make. That's all I'm saying.
No, but we're challenging that statement that you just made. That it makes sense.
Saying you're wrong.
When I'm done
It doesn't
with this,
make
I'll
sense.
get on the computer and I'll show you why.
It doesn't
okay?
make sense even in their model, because you still need line of sight. And then if you do, then there's things between those two things. Things meaning clouds or something. I mean, there's lots of things in the atmosphere that could be absorbing light and we would see it.
Let's let Bob go off and to do his thing on his computer, and then we can come back and touch on this.
Yeah,
when
that's fine.
when
Yeah,
he's
I
ready.
will.
I mean, how is that, like, that just doesn't make
Me
sense.
too.
How is the moon the only thing out there that is able to receive the light that's, let's say it does have an ability to get to it? How? Like what? Like gravity? Just attracts all the light rays to it and only it?
I'm not going to have any answers for those kinds of questions. I promise. I'm not.
You
one
own the
will.
globe now. Just to be clear, Bob.
Yeah, you're on the hot seat now. So just be a baller for a few
It's my
minutes.
baby now. They dropped it off on my doorstep.
Yep.
Because they don't want to defend it
Taking
because
in
it's
the orphan ball
ridiculous.
model.
All right, number 5.
How do you just quickly, another thing, how do you get the sun and the moon in the sky at the same time and it not be a full moon? How can there be a shadow on the moon?
Saying that forever.
Now there's an argument you should make.
So here you go.
Because
Okay.
there's nothing obstructing. If it's a specular reflection, there's nothing obstructing.
Only
You
that.
just
They're in the
assumed it's a
sky
shadow.
together.
Hold
Why
on.
is it? Why'd you call it a shadow?
The termination line. The termination line. There should be no
Terminator line. There should be no terminator line there. Thanks.
Now think about this. This is a little bit about what we did a while back. If you guys remember that photograph that had the moon really close to the Earth, and it looked like it was out of proportion. We talked about it for a while. I can't remember what the source was, but so to piggyback off on what Effie was just saying, you have to. I think that this is more of a strong point to make. If you have an infinite light source, such as the sun, the moon will always fully be in the direct path of that light source. The only way you could have a terminator line on the moon in the proximity that it is to the Earth is if that moon shot the fuck millions of miles away to get at a different angle. Absolutely no way you could avoid not having a full moon every time the sun and the moon are in the sky at the same time. Absolutely no way.
I agree with that, 100%. It's engulfing the whole thing, whatever it is. So yeah, agreed. So it's clearly operating independently.
All right, number 5. The lights which are exhibited in lighthouses are seen by navigators at distances at which, according to the scale of the supposed curvature given by astronomers, they ought to be many hundreds of feet in some cases down below the line of sight. For instance, the light at Cape Hatteras is seen at such a distance, 40 miles, that according to theory it ought to be 900 feet higher above the level of the sea than it absolutely is in order to be visible. This is a conclusive proof that there is no curvature on the surface of the sea, the level of the sea, ridiculous though it is to be under the necessity of proving it at all, but it is, nevertheless, a conclusive proof that the Earth is not a globe.
But you
Very
don't
tricky
understand
writing
refraction,
style.
Brandon.
Basically,
It's
he's just saying you see
refraction, man. It's refraction.
Yeah.
Yeah, I guess he didn't know that light bends to make the Earth look flat. 40 miles. Yeah, that's a pretty good distance to see. What 40 times 40? What is that? 1,600 times 2/3? That's a good bit of curvature. Yeah, about 900 feet, right? 900 plus feet.
Yeah, that's pretty far.
Right? What I found interesting in here was he says supposed curvature given by astronomers. He didn't say surveyors. He didn't say anything else. He said astronomers.
Well, the curve line compared to the chord is only off by 2.5 inches.
Bro, the only way
According-
you can tell how much the curvature is if you look in the sky. Come on, bro. You don't understand.
Right. Exactly. So even then they were it was all coming from astronomy. 6.
I'm still having a hard time buying that, man. One more thing with the straight line, since he's talking about distance, because if you take a cord and pull it tight, just picture a cable that or a piece of rebar that doesn't bend, and you stretch it 40 miles, and then it's dead straight, and then you got two of them side by side, and then you got to pull the other one up 900 feet in the middle. How the fuck is it only off by 2.5 inches, man? Something's got to be wrong with math, but that would be in a perfect circle. But it still doesn't make sense in my mind that you could pull the middle of that piece of rebar up 900 feet and still be equal end to end and only stick out an extra 2.5 inches. It just doesn't sit with me, man. But I had to reluctantly accept it that that's the math for the exact sphere.
It has to do with the scale that we're looking at, because even 40 miles you're talking about just like nothing in comparison to how big the Earth is. So it's just all about scale. Yeah, if you talked about 4,000 miles, then that'd be a sizable difference between the core and the arc.
Do you see the problem though? Is having the two side by side and having to pull the one in the middle up 900 feet, a 240-mile piece of rebar, and having to bend the one up 900 feet. That's what you'd have to do on a globe. If that math is correct, you have to bend the middle up and away from the other one in the middle 900 feet, yet it only affects it. Yeah, it's just the distance and the scale of it, I guess, but it's still hard to fathom, bro.
Oh, I know, no, it blew my mind for a while too, but 40 miles you're talking about what's 200,000 plus feet? See, so it'd actually be more like 225 feet at 40 miles that you'd have to pull up in the middle. But it's nothing. 225 divided by 200,000.
Well, 40 miles is nothing. We got greater than infinite over our refraction, so you can have anything.
Yes. Yeah, that's true.
Could have been 200 miles. It's fine.
And even straight lines are curved infinitely, so it doesn't even matter. Yeah, so that's an interesting one. I'm with you there though, Brian. Number 6. If we stand on the sands of the seashore and watch a ship approach us, we shall find that she will apparently rise to the extent of her own height, nothing more. If we stand upon an eminence, the same law operates still, and it is but the law of perspective which causes objects as they approach us to appear to increase in size until we see them close to us the size they are in fact. That there is no other rise than the one spoken of is plain from the fact that, no matter how high we ascend above the level of the sea, the horizon rises on and still on as we rise, so that it is always on a level with the eye, though it be 200 miles away as seen by Mr. J. Glacier of England from Mr. Coxwell's balloon. I don't know about that, what he's referring to there. So that a ship 5 miles away may be imagined to be coming up the imaginary downward curve of Earth's surface, but if we merely ascend a hill such as Federal Hill, Baltimore, we may see 25 miles away on a level with the eye that is 20 miles level distance beyond the ship that we vainly imagine to be rounding the curve and coming up. This is a plain proof that the Earth is not a globe. That's a
Beautiful.
lot.
Beautiful.
Yeah, that's a lot to unpack there, but we still talk about that all the time.
Yeah, I mean, I think we looked at it just the other day, the Southern Cross boat footage with me, when we're talking about, even though there was an inferior mirage, we're talking about the travel of a ship over the extended plane of water.
Yeah, exactly. Yeah, we were discussing that very same thing. Yeah.
I had to watch that again. That was a great presentation, dude. And God, all the shit all the hours you put in, but God, you got some good demonstrations, man, to prove your claims. Flat out prove them. Like Ed was watching that night, and he just went quiet, man. It's like I haven't heard, like he never even seen it, and he's watching that reflection get bigger and bigger till it works its way up to the deck, and it's like he just doesn't want nothing else to do with it. I mean, how come they don't comment on these obvious proofs of at least another factor, or I mean another explanation, right? They won't even acknowledge it.
Yeah, they do. Brandon, you remember the last thing that you said after I finished my conclusion? Remember what you said?
No, what did I say?
You said that really made a lot of sense, and Ed said, "How did that make any sense?"
Oh yeah, he always says that. Yeah, that somebody always says that. Every time I say that made a lot of sense, when someone gives a presentation, somebody always says, well, "How did that make any sense?" Every single fucking time.
There's no point in talking them optics if they don't recognize that objects can obstruct bottom up across any surface, every surface. So they won't get it. So they'd have to go to Life is Short or somewhere, maybe do a test on their own.
The
They
acute
won't
angle
acknowledge
alone.
that.
The acute angle alone will make something disappear.
I'll give Pompous this too, man. I ain't giving him much, but I'll give him this. He does acknowledge that there's that you wouldn't see Spain from the coast of the United States. He knows that there would be a horizon on a flat Earth. You know, he don't agree with it, but he does acknowledge it.
I mean, you'd have to be completely retarded to not like that's horrible. I get that. That's fair, but we're talking about locally objects across a flat surface. Carlos admitted that it's possible because I think there's too many examples of it now, and I don't know if Rumpus has admitted that. But once they admit that, then it does put all of their analysis in question. They have to consider it.
Yeah, you're right, though. It's not much of an admission. It's like not much of a compliment either, Brian. It's like saying, well, Rumpus knows not to eat his own shit. I mean, I'll give him that. At least he knows that.
Yeah, right. But no, it's still, it's like, it's good talking to people, at least who understand what you're saying. Like, they just for so long act like something that's higher and something that's higher in the distance can't be lower just because of geometry. It's like, it's perspective, man. If something's on the horizon on a flat Earth, whether it's flat or a globe, if it was flat, a skyscraper would be a speck on the horizon, and something only 10 foot tall, just a couple foot taller than you, would tower over it halfway there. I mean, but and light has it's just, dude, when you get so tired of arguing with people who act like they don't even understand it, and it could never even work, there'd never be a horizon on a plane. Like, dude, I'll just show you an example of fog. And a horizon half a mile out in the distance. There's a horizon, call it what you want, but it's a damn horizon. You got to go through such extremes, and they still don't get it. At least some people are worth talking to,
But here's the deal, Brian. Like in the extreme, right? Locally, both surfaces act the same, and in far distances, they act the same because light will attenuate. So it's kind of this middle range that we're debating, 5, 10, 15 miles. So for somebody to not acknowledge that light attenuates over whatever, however many thousands of miles, I mean, that's not even a person who has a brain. So Rumpus has to say that. That's not even a geometry question.
My favorite one is there won't even be a horizon on a flat Earth.
Oh, it's
exactly.
so dumb. It is so
Brandon,
stupid.
I'm ready.
Oh, cool. Yeah, let's go back to that then, Bob. We'll take a break from
Okay,
going through this.
so I'm going to state this. I don't think the Earth is a ball. I don't think it's spinning and flying through space, okay? I don't think that this is legit in any way. But I'm going to try to display to you what they're thinking, okay? I had this Negator was in here like months and months ago, basically having this conversation with someone. I pointed out that technically what Negator was arguing did make sense within their model, okay? And they might actually be claiming a different position of the moon along with it, which would just make more sense in their model. If we're going to step into their model, we have to play by their rules suddenly. I don't think that's a good idea. But here's why you could technically do it in their model. Or at least one of the ways. They might even be making a different argument than this, but here's one of the ways you could technically do it in their model. Let's see here.
Okay, so this is a presentation of your personal beliefs. Got it.
Yeah, we just use different language because we'll get offended.
No.
It's not
Okay.
that's how you
Jedi wanted
do
to
it.
speak on this too, to say that it's in their model. It's not just what he's saying as well. There's many people that claim, yes, not just claim, but can state and tell you that this will work in the model. Go ahead.
So Jedi believes this as well.
That's their explanation.
Okay.
Oh boy.
Go ahead.
It's
Bob.
different.
All right, Brandon,
hold on. Let me see.
Is my screen up? Is my awesome picture in Paint up?
1 second. I got to get it over for the audience.
You've taken all that time to draw that, Bob?
No, I was doing something else. I didn't do this until just in the last couple of minutes. I was playing a video game.
Hold on.
Hey, you respect my artistic
3 hours.
talent,
3 hours later.
son. Okay.
All right,
Come on,
let's summon the rumpus. We need proper diagrams. Let's get rumpus in here.
So now, here's one of the ways it could work, and I think this is basically
Can you
the
make
same
it a little
argument
bigger,
they make
Bob?
for the stupid
Can you zoom in a
moon,
little? Sorry.
what is it, lunar eclipse or whatever. It's really dumb. Okay.
Bob,
Bob, can you
What?
zoom in a little?
listen,
What is that thing that you drew?
I'll zoom in.
Okay.
Yeah.
Bob,
Okay.
All right. Okay.
It's a potato. That's what it is.
Okay.
Bob, listen to me.
So it's not a circle. Okay.
Bob,
What?
You do know that
Just seen it just popped up, the yellow circle.
Did you not have a circle tool, Bob?
Oh, I do actually. Do you want me to fix it?
No,
my
no,
goodness.
no. It's fine.
It doesn't matter. Listen. Here, my picture is possibly less ridiculous than their model. Okay. Now,
keep
shut
going.
up.
Yellow was a bad choice, though.
There you go. You win.
Now, here's the
Go.
Earth, and here's the sun, and here's the moon in their model, and you can put this moon here or here or here or here. It doesn't matter because the sun is so dang big in their model in such a stupid way that the light from up here can hit anything in here completely on its surface, entirely lighted up. That's how big the sun is to them. They think it's that big. And it's basically the same claim they make for the lunar eclipse whenever they go ahead and they put the stupid moon right here. Well, guess what? The light can come from way up here and hit everything in here and then cancel out part of the shadow. That's how dumb they are. So that is not the point that you should try to argue and convince someone on.
Right.
Thank you.
No, it's
Presentation over.
a great.
Good job.
It's a great point to argue because it's so ridiculous. It has nothing to do with the size of the sun. It has to do with line of sight. It has nothing to do with the size
A
of the
quick
sun.
question, Bob.
If the
Are you
sun
gonna
is
pick
big
that
enough, it
diagram
doesn't
from the
matter
bridge?
if the Earth is in front of the moon because the light can hit it. Light doesn't travel in one direction.
But
It travels
don't
in
use
all
the
the
size of
directions
the
because
sun.
it's the sun.
They're arguing line of sight, right? Because that's the way something can get illuminated or reflected or whatever. So size of the sun is irrelevant. So you're saying that that other person made a defense that some angle can allow the sun to still be able to interact with the moon. Okay, fair enough, because they're not antipodal. That was the argument, you know. And so fair enough. Okay, let's say the moon moves over a little bit so it can kind of touch some of those rays. Yeah, but there's still things in between that path.
No,
That's
okay.
the
I
problem.
think you're misunderstanding. There is line of sight. That's the point.
I know, yes. And my argument is that in their model, there's things between that would need to be illuminated as well.
What are you talking about? What's in between there?
What
Between
in
the
their
Earth and the
model,
moon?
What do you think is between there? What happens in
Bob's
between the
diagram
moon and the
sort of
sun that are
makes
so
sense.
far away in their model? Nothing? It's just a vacuum?
Yep.
That's what they claim. Yeah, they claim that we're in space, dude.
No, but name one thing that is in between those two things. All the
Between
time.
the Earth and the moon?
Between the sun and the moon.
Nothing.
Well, they say that the
One
Earth
thing-
sometimes is, right?
Except when Earth gets in the way and causes an eclipse.
when it's on the other side.
When it's in the right position, yeah.
Right.
I don't know if there's any other objects that they claim is between, like, specifically the Earth and the Sun while the Moon is over there. I don't know.
That diagram
Hey,
you just did.
it says on one of their websites that the selenium is
Will you put that on your fridge for me, Jeremy?
impossible. They do
It's going in the top 10, bro. That's top 10 right there.
Y'all hear me? They do admit that
Probably
the selenium is
well on.
geometrically impossible.
Yeah, refraction, I think, is what they say that causes you to be able to see this.
If they make the sun big enough, it will always have line of sight. That's the thing.
Right.
No, not if it's so far away as they say. So that's not right. You know, but they probably think it is.
Say that one more time, Mr. Copenhagen.
There's no line of sight, because if that's the scale you were drawing just a minute ago, you have to throw that little blue dot out the window before you're even close to see how far the Earth is from that sun.
Yeah,
are you implying that their model is somehow incorrect or maybe retarded? Because if you are, sir, I 100% agree.
No, I'm not. No, I'm not. No.
You should be, because it is. It is
Are you
retarded.
saying that picture wasn't? Are you saying that picture wasn't accurate and to scale?
I'll tell you the scale though, just so people can get their head
that's
wrapped
what I'm
around
saying,
it.
yeah.
Here's the scale. A bowling ball. Take a bowling ball, and then take a little tiny pebble, like a 2 millimeter pebble, and walk 77 feet away from the bowling ball. The pebble is Earth, and the bowling ball is the sun.
Yeah.
And there you go. And the moon
So the
would be
scale
like a
is
grain.
more extreme possibly than I even put it in.
And then you don't no longer have line of
for
sight.
the sun, and then take a like a marble for the Earth, and then take a P or a BB for the moon. It's still going to be hidden behind that marble, you would think, but I don't know.
It is.
I like his demonstration of parallel sun ray.
This is it.
Did you
This
say
is
17 or 77, Brandon?
77 feet, roughly. Yeah, that's what I calculated as. Yeah.
Okay.
Roughly.
Would you like to?
Yeah, I think, is it okay if Jedi speaks on this too? I think he's actually going to agree with this crazy diagram. I'm sorry,
Well,
I have to say
it's-
it's crazy too. It's a little bit
one-
out there, but I love it.
Would you
One
like
of
to
the
see a
interest-
scale diagram of the sun and moon and Earth so you can appreciate it?
Sure. Let's let Jedi. Let's let Jedi say what he had to say.
Wait a minute. Wait a minute.
Calm down.
Wait your turn.
I thought
Rumpus.
I was the one with the diagram here. You guys just gonna call in someone else for a diagram now?
No.
Like why? Why would?
I
Why?
promise.
Well, when it comes to diagrams, we are
The chief
You are
liar
on
has
a scale
arrived.
diagram, and I've got one ready if you want to look at it.
All right, hold on. Go
Well,
ahead.
but
Share
in
your
time,
screen.
in time.
Jedi, go ahead.
It's the interesting point. All I wanted to point out is the light rays from the sun, divergent or parallel. Which one for this argument? So are they parallel light rays or are they divergent? This
Don't
time?
get him
Rumpus,
started,
this is
dude.
bad. What are they?
It's whatever
Well,
he
it all
wants.
Whatever's more convenient for the time.
Right. Well, the thing is,
But
the
the-
light leaving the sun is divergent, but to arrive at a particular point on the Earth, only the rays that converge on that position you need to consider. So it all depends
Bring up
when
your
you're considering.
diagram.
So I can show you a diagram that
Bring
will
up a
demonstrate this.
diagram. Yeah,
I'll
bring it up.
the diagram. Okay.
Some of the light rays hitting Earth in your model should be parallel, and some of them should be not parallel. Is that correct?
Yeah, it depends which ones that you select. But if you're on a particular point on the Earth, and the only
Oh my
light
God.
rays that can reach you are ones that are say from the left and the
Keep
right.
in mind that there would be like basically an infinitesimal amount.
Can I just
of,
finish my sentence? So just imagine you're looking at the
Right.
sun.
Yeah.
The only light, the light that's coming from the left-hand side of the sun, has got to be angled towards you to get to hit. Oh, let me finish, Jesus Christ! And on the right-hand side of the sun to reach you, because it's got an angular size of 0.5 degrees, there's a span of 0. Jesus Christ, nearly there. And so to reach you, there's one that's got to be angled one way, and one has got to be angled. If they just consider the parallel light from the sun, it would Jesus Christ, the bits from the left and right hand edge wouldn't hit you.
Can't you be
Finished.
like equal opportunity blasphemer? Is that what it sounds like when Rumpus eats his own shit? Because that's all that just came out of your mouth was just shit.
Well, in which case you're just so stupid you can't understand simple geometry. I can show you a diagram if it'll help. I mean, Jesus Christ. I mean, a 7-year-old should be able to understand. I mean, literally a 7, 8,
I don't
or
see the sun
9-year-old
in
should
this
be able to
diagram.
understand this.
Well,
Where's the
opportunity.
sun?
Okay, next time, like curse Krishna and Muhammad. Why you always gotta cuss Jesus, man? What did he ever do to you, bro?
Yeah, that's a bad idea.
Rumpus, do you have one of those scale diagram thingies with the sun in it too, and not just
Yes,
the
I
Earth
do.
and Moon?
Yeah, okay. Yeah, okay. Which one do you want first? Okay, we'll do that one first then. Yeah, with the Earth, Moon, and Sun and everything.
Right.
So, can you see this?
Yeah,
I'm
there you
sharing
go.
now.
See,
Yep.
there.
Everything.
Can you see my screen? Am
Yeah,
I sharing
yeah,
properly?
Yeah, I see
Oh,
it.
great,
I
okay.
see it.
Right. So
Everything. You said everything.
right. So here is everything. Yes. So here we have the Sun, and here we have Mercury and Venus. These are the
I mean,
positions of them, the Earth and
you
Moon.
you just looking at that, you realize how stupid it is now, right, Rumpus?
Do you realize how stupid you are?
I mean,
by
no,
not
look at that
understanding
thing. Look at that thing, Rumpus. Come on, dude.
What's It's just simple. You don't
There's a
understand
little
the space.
glowing fucking ball
You
93
don't
million miles away,
understand that space
shining its
is
light across in all directions and hitting us,
very,
or a little dot
very,
floating in a vacuum. Give me
very,
a fucking break. Go ahead.
very,
Continue.
very big.
All right, drive a
Space-
rectangle. Draw a
You want
rectangle.
to read some Douglas Adams in which he describes just how big space is, and it's very, very big.
Shouldn't
So
the sun be
anyway,
bigger than that on the scale?
right? So well, yeah, but I haven't shown you the Earth yet. So here's the Sun.
Wait,
and-
Rumpus, what are you demonstrating? Just to clarify. What
Oh
is this?
my God!
What are you
I'm
showing?
demonstrating what I've got in the title here, the scale view of the geometry of a solar eclipse. So I'm showing you, I'm going to show you the relative sizes and positions to scale of the Sun, the Moon, and the Earth, and the
Why
position.
aren't you doing it? Why aren't you doing it all in one?
We were
Because
doing a full moon during
Yeah,
daytime.
we were talking about a moon
the
illuminated.
scale's way off
Oh,
here. Bro.
right, but it's basically the same argument.
Yeah, I'm showing you how the Moon and the Earth and the Sun have the relative scales. That was
We're
the
asking
issue.
how something with an
No, it
object
wasn't.
between it and the sun is still going to get light on the entirety
Yeah,
of
and
its
I'm showing
surface
it
or
for a
whatever.
solar eclipse. So I was
Exactly.
showing that. If you give me a chance,
The
I'll be
size
showing you
scales
how.
here.
Will you admit that?
The
Will you
size-
admit that NASA admits that the selenium is geometrically impossible?
Yeah, it's due to refraction.
The size in your
See,
chart are not to
See,
scale.
you would not believe how many
absolutely to
times I
scale.
get.
Jeremy, this is
He's sometimes
absolutely,
honest.
absolutely to scale in every regard.
No, it's not, because the sun is a little tiny ball that floats above the Earth. What are you
distances of
talking about?
things, the size of things, this is absolutely measured accurately to scale.
No,
okay?
it's fantasy land.
So
Sorry,
it's
hold on.
accurately
Sorry, 2
to
seconds.
scale.
What?
So
No
everything
way.
in this is to scale.
You
No
said
fucking way.
measured. Measured the Earth.
What? It's to scale.
You
Everything
said-
in the diagram is to
It's
scale.
not. No, it's
Yes, it
not.
is.
That's a lie.
I'm
That's a
telling you
lie.
it is. And the
Look
fact
how
you
big
reject-
Earth is and how big the sun is. Are you
I'm going
serious
to
right
show
now?
you that in a second.
No, I'm looking at it on your screen. It's not to scale.
What's
What do you
not
mean?
to scale?
The size of the sun and the size of Earth.
No, I haven't
And
got.
all the-
you
all the
can't
shit in
see
between.
Earth. You can't see Earth in this at this scale.
Yes, I
It's
can.
too
It says
small.
Earth Moon system, and there's a picture of it right
Yeah,
up
and
there.
that picture is
It's
not.
the system, I think, maybe.
That's the system, and it's scaled up there. I will show you the actual size of the Earth in a second. Stop jumping to conclusions. You'll see it in a second. So here we have the sun.
Wait for the
and
big
there we-
reveal.
And here we have the Earth-Moon system. So let's go and bring that into the center of the picture, and let's zoom in. And this thing you were looking at is not the thing. That's an enlarged version. There is the
See,
size of the Earth.
I'm on the
There
Earth. I know it's a
are-
lot bigger than that.
Right, and there's the moon
Wow.
over here.
Control Brandon, best Brandon. No.
There's the moon here, and there's the Earth. And this thing you perceived as being the size of the Earth was just this diagram showing you the relative sizes of the orbits of the ISS and Hubble and things, and then I put the moon together just so you could see it more clearly. But
I didn't
that's
realize you
it.
had fairy
there,
tales in this
that
diagram. Okay.
is the relative size of the sun. There's the relative position and size of the moon to the. So you can see it's a lot further away than you might think that moon thing. So
Well, I like Indio's. Hold on.
So
I
anyway,
like
so-
Indio's question. When
Let me
when
show
did you
again.
measure
I'm
them?
going to emphasize just how small that is, and there
Hold
you are. Just to emphasize, I'm zooming in like crazy here.
All right,
There we are.
draw a
That's
rectangle.
relative Scales. So there
Draw
we
a
go.
rectangle. Rumpus, draw a rectangle
no, I
around the
won't.
sun.
No, I won't.
Rumpus, do you touch yourself with diagrams?
Where's point G?
Listen, draw a triangle around the moon.
Stop being
and
silly,
Earth.
Jeremy. You've this
None of
hopefully
those
will
are
make-
the
so
sun
that all the
or
points
the
you were
moon.
making earlier about the obscuring of them, you can see that the moon is sufficiently large, even though it's quite a long way away, to just
Jeremy, I'm not sure that you appreciate the dedication and time we put into making our very scientific and accurate diagrams, me and Rumpus. We're
Yeah.
basically this. We're
I
the
mean,
same when it comes to
Rumpus's-
diagrams, as you saw earlier.
Rumpus's diagram's almost as accurate as yours was a minute ago.
I did
Find
some
out.
quick math and calculations, and that diagram earlier set flat Earth back 4.2 years.
Is that all?
Did you say scientific?
That was fucking great. That was great.
And this black thing here is the shadow of the moon, which is why it's an eclipse, and you can see it just manages to get as far as the Earth, and that's why we have
that's not
solar
what happens.
eclipses.
Yeah.
That's exactly how it happens, Brandon. 7-year-old
Hey,
should understand this. I know you're a
Rumpus.
reality denier, but this is what the count saw it.
This is
No,
not
a 7-year-old shouldn't understand this because that would be like indoctrination and possibly child abuse.
They
So
might ask
7-year-olds should not
questions.
understand this.
You're just a reality denier.
Which,
I mean,
hold on, sorry, I got to interrupt. Which, sorry,
this exactly
Rumpus,
matches
my
reality.
apologies.
Well,
This is
apologise.
the bit.
This
Oh,
matches
okay.
reality and matches observation.
Excellent. That matches
All right,
reality.
Rumpus.
Can you give me a physical demonstrations of any of the three claims within that model, as in the curvature of the Earth, the motion of any of these things, or the place where all of these things reside? As in, can you demonstrate gas pressure without a container? Which one of those claims can you physically demonstrate? That's your model, right?
Right.
Ball,
yeah.
motion,
Well-
gas pressure without a container. So
Okay,
which one can
well,
you physically demonstrate?
All of them.
Where's that?
Which one do you want to start with then?
You need it.
Well, I'll let you pick.
Okay, gas pressure without a container. Let's go.
Right, go outside. There's no container. We know there's no container of the Earth.
Oh,
and
hold on.
Go outside.
Wait a
Sorry.
minute.
Go
Can I-
outside.
Very quickly. Very quickly.
There is
So
no
you've just
container. There is no container
Sorry.
for the Earth, and there we have gas
I
pressure
get you.
without it. Finished.
okay. You do understand that that's just you and your belief. That's not a demonstration. That's just you going outside.
There is
There you
no
go.
container. We've shown
Okay,
there is
sorry
no
guys.
container.
Sorry.
So that's a physical
So
demonstration.
very quickly, Rumpus. What you've done is you've made a declaration. You haven't physically demonstrated it. You've just pointed it and no, hold on.
Go outside.
You've just declared exactly. Declare. All right. I want a demonstration of that I can physically do of a mass attracting gas to it, or a non-physical boundary of the volume of gas and the volume of gas staying in that.
He's
Right,
asking
so
for
I'm
him.
going-
That is a physical demonstration. That is a physical demonstration. There
Just a
is
real
no
quick-
container. We know there's no container. Therefore, that is a physical demonstration of gas being attracted to the Earth and being held to the Earth and having gas
hold on.
pressure.
It seems
Hold on.
like maybe
So,
he doesn't
gas-
understand what
2
a
seconds.
Hey guys, let's
demonstration
let
is.
Jedi and
Hold
Rumpus
on.
work this out and get to the bottom of this. I know we're going to get a demonstration. Jedi, Rumpus, you guys have the floor.
Thank you. So you're saying that gravity is attracting the gas to the Earth. Why is the
Correct.
gas going up and in all directions then?
Because you don't understand the difference between velocity and acceleration. The gas is accelerated just like a ball. Let me finish. Let me finish a goddamn sentence for once. If you throw
just
a
said
ball,
okay.
let's shut up. So when I throw a ball up in the air, it has an upward velocity, but it has an acceleration downwards. That's exactly what the gas molecules do. They're running around in all directions, but they're being accelerated down. Shut up. And when they come down the direction,
Say
then
anything,
they will
you
be
idiot.
quiet, twat. And so when they come down, they're accelerated down. Some of them will then hit the ground, and just like a bouncy ball, it will then go back up again. So because atoms and molecules do not that have perfectly elastic collisions, they don't lose any energy. So if you were to drop, for instance, or throw up a ball at 500 meters per second, and imagine there was nothing for it to hit, because obviously gas
Awesome.
in the way. Listen,
That's
it would
brilliant.
get up to a height of about 100 kilometers, and
Haven't
then
given
it
me what I
would
wanted.
slow down on the way up to 100 kilometers, and then it will come back down to Earth. And that's exactly what
lovely.
molecules do.
No, so this is a red herring. I want you to demonstrate. Hold on, Rumpus. I want you to demonstrate a mass attracting a gas to it. We know that gas disperses in all directions and is the thing that's in motion and presses on the walls of its container or any surface. I want you to show me that surface, the mass attracting the gas to it. Go. Show me that.
The atmosphere does that. It's a demonstration of that very
I want
thing.
no. That's just your declaration based upon your
No, it's
belief.
not. You know that the gas is outside. You can go out
Yes,
there.
it is. I'm breathing it.
Right, great.
But
So there you go. So there you have
I don't live. I don't live
for
within your
you
belief.
that there is
Rumpus.
a gas. It's not a belief. You
Rumpus.
can go out and
It
demonstrate.
is. You've just declared it.
Okay,
and it's not just a declaration. We can all physically experience it. You idiot.
Excellent. So show me a mass attracting a gas without your belief involved. Show me it.
You can do it. You're not you don't have my beliefs and knowledge of science.
No,
but even
right, let me
you can
explain.
go outside. Let me
Rumpus,
finish
let
the
me
goddamn
no,
sentence, twat.
because you're
Be
not
quiet,
answering my
be
question.
quiet. I'm
Why are you
answering
calling
the
me
question,
a
twat. Be
Why are you
quiet.
calling me a
Be
twat?
quiet.
I haven't called you anything. You're
He's
so
asking
rude.
you to prove
You're
his claim
interrupting me
now.
systematically. I let you speak. So if you go outside, you will
Actually,
experience.
you've been
You
speaking
will
and
experience.
speaking and speaking.
You
Right,
will
speaking. This is what you
experience
do. This is what
the
you do.
gas
I'm not gonna let you
being
talk.
held
Wait
to
a
the
minute,
earth,
wait a minute. No,
and we
no,
know
no.
there is no container. Therefore, that's exactly the
No, you
demonstration
don't.
you
No,
asked
you
for.
don't. You're trying to literally prove exactly in the let's just prove, right, that we live in an area, right, it's open and we don't need to have a container. So the only way to prove that is not to sit here and show exactly to me what we're trying to prove. Show it to me.
Well, prove it.
Don't give
Prove
me
it
the
wrong.
same thing we're trying to prove.
I have a question.
But
Prove
it
it
is
wrong.
proof. We know there's no container. Sorry, who was that? Like, was that you trying to speak left?
No.
No,
Yeah, I was just saying. I mean,
I've been-
Rumpus is presenting his case, and y'all should have to prove it wrong if you say it's wrong.
I will do that.
No, that's not
So
true.
I will
That's
do. Sorry,
not how it
I will
works.
do that right now. So I can demonstrate that gas disperses in all directions, and inside the container, it is pressing in all directions. Now I can demonstrate that. What Rumpus is failing to demonstrate is a mass, I don't care how big it is, and gas being attracted to it. Not going in the direction of the surface is going to press on. The surface, the mass attracting the gas to it, because that's the claim. Mass attracts gas. So show me that. Show me
That
a
is
mass
the
attracting a
atmosphere.
gas to it.
That is the atmosphere.
Right, so the gas
Yeah.
is in the
Can't show it to
atmosphere.
you.
Hold
That's
tight,
why he
hold on.
said you can do it.
Hold tight, my
Sorry.
friends. The gases in the atmosphere are going in all directions.
But they're
I want a
accelerated
gas. Hold tight.
downwards.
Don't
I
listen.
haven't actually been able to answer your question yet. I've been interrupted twice by other people. So
That's lovely.
gas. Stop saying love, stupid twat. Stop being a twat.
Why
So
are you calling
we
me a
know-
twat?
look, yeah, I'm calling you a twat again because you keep on interrupting me systematically as some sort of because you can't cope with the answers. So here
No,
we
I
go
can
again.
cope with it, but you're not giving me the answer that I want.
I know because you don't understand. You were science
I
denier.
do.
You don't like reality. I
Oh.
know you don't.
Oh,
So
here we go.
again. So the gas.
So show me in reality the claim that you are making.
Be quiet. I'm going to give you an answer finally, hopefully. So here we have the atmosphere around the Earth, and it is attracted to the Earth because it doesn't disperse into space.
can't
And we've got pictures of it being around the Earth. So therefore, we have an example of a mass, the Earth, attracting gas, the atmosphere, and we have pictures of
Testify,
this.
brother. Testify. I don't want your belief. I want a physical demonstration of mass attracting gas.
You understand that the
Do
atmosphere is
you
not
know what science is? Hold on, hold on. I want a physical demonstration that I.
You
Excellent.
don't seem to understand
So
the evidence
I
I've presented has got nothing
require
to
a
do with my
physical
belief.
demonstration
Go
of your
outside,
claim.
you've got it. Go
No, I
outside
don't.
and you've got the demonstration you're looking for.
So he's not going to accept.
No.
He's not going. He's not going to
Sorry.
accept.
You keep on
Can
asking
I-
about my belief, and you can go out and
Rumpus,
experience it
Rumpus,
yourself.
listen, that's the question I'm trying to answer. So I need
No,
a demonstration that
and it
goes
is a
against reality.
demonstration.
No, it's not. That's the question I'm trying to answer. How does that
No,
happen?
no,
You're just
you're
declaring
asking
it
me
happens.
for physical
So I
proof
want a demonstration
the
of
gas
your mass
is
attracting gas.
attracted to the
But don't want you
Earth,
begging the question,
and it
my
is.
friend.
There's no begging the question. It's empirical.
You are.
No, there's no.
No, it's not,
question.
because you can't demonstrate it to me physically.
No, twat, no twat.
Mm.
No,
Oh,
there's
twat.
nothing. There's
I
nothing.
like you.
There is
You're
nothing.
funny.
This perfectly
Okay.
empirical from first principles. You can go outside and experience
Empirical.
gas pressure. So that has got
Yes.
nothing to do with begging the question.
What
That's
is the antecedent of gas pressure?
There isn't one. So
There's an antecedent.
no antecedent.
Can't
There is
demonstrate
no.
for God's
Hold
sake.
on.
It's in the
Right, you're
definition.
moron.
Rumpus.
Sorry.
So you're
Sorry.
a moron.
One question.
In
I
the
mean,
definition.
you
Sorry.
obviously don't understand what
Rumpus.
empirical means,
Rumpus.
and you don't understand what a demonstration
Rumpus.
means, and it's got
What's the
nothing to do
consequence?
with my belief. Be
A
quiet.
bunch of
Rumpus.
declarations.
I'm in the middle of my sentence, then you get your turn.
Sentence.
There is
See,
Rumpus,
this
what's
is
the
why
consequence
Nathan
of
I
just
will-
gas?
mutes
you get your
in and
chance in a
says what he
second.
needs to
My
say because
turn
you
to
don't
speak,
get a
and
chance to
then
say
you
it
get a
if you
turn to
don't
speak
mute
next.
him.
So here we go. So there's nothing I'm using. I'm not even using a logical argument. I'm not using my beliefs. I'm just telling you to go and empirically experience or even measure the pressure outside. That's an empirical thing. It's nothing about begging the question.
Rumpus, we can demonstrate a gradient contained. We can't demonstrate one not contained,
please.
bro.
You can get a chance in a second. So it's that you don't seem to understand what an empirical fact is. And it's an empirical fact, not based on any question, any premise. You can just go outside and experience it.
Excellent.
Finish.
Thank you, Ranty. Just a very quick question. What's the consequence of containing gas?
Lots of things.
Okay, so what happens to the gas that's inside a contained environment? What's the consequence of containing it, Rumpus?
What it got to do with the atmosphere?
Well, yeah, exactly. I'll indulge.
Let me.
I'm prepared to
Either indulge me or I'll explain.
I'm prepared to accept any question on anything like this, even if it's a stupid one. So when you have something in a container, the molecules or atoms in the gas will collide with the container. So,
So, as a consequence of containing that gas, is there now gas pressure?
There's always gas pressure, whether there's a container or not.
There's always gas pressure. Hold
There's
on.
a very important point to this. Hold on. I've got a very important question to ask you.
Literally can't
Do
talk
you
to you, can I?
believe there is gas pressure in the middle of a container?
Yeah, there's gas pressure.
No, you can't
everywhere.
talk. Hold on. Let's stop interrupting, Paige. Let's get this out. Do you believe there is gas pressure in the middle of the container? Shut up, stupid bitch. Do you believe?
Whoa! Hold your fucking mouth right there. No, you don't speak to women like that. No, I don't talk to you now.
She was quite rude to me then.
Don't care. You're done.
It's over.
All right. Good show,
Rumpus, the gas in the middle of the
Come back
container,
tomorrow.
just so you know, it's moving. It's not just sitting there. All the gas is moving, bouncing
The whole
off the
point
wall.
is we can show a gradient in 3 different ways. We can show a gradient contained. We can't. Well, 2 different ways. Just put a pipe
Rumpus.
up high up in the air. If it's contained, you can measure the gradient. If it's not contained, you can't measure it.
Rumpus
But
was
look,
getting ready to ask. He was getting ready to ask because he was saying, "Do you believe there's gas pressure in the middle of the container?" So I know where he was going. He was going to say, "There's still gas pressure there." That's why I was telling him that gas in the middle of the container isn't just sitting there. All the gas is bouncing, moving in all directions, causing the pressure.
Tell me this: what is wrong with the definition of atmospheric pressure?
It's just a gas law, man. Look, there's got to be. We can show gradients contained. We can by getting a pipe and heating up one end and cooling down the other, just like the atmosphere shows. But it's still got to be contained, Howard. You can't show gradients without containment, except by saying, "Look up there. There's no containment, and there's a gradient." That's assuming, man. And he won't. If he'd addressed that, I'd have been fine.
You can measure the gas pressure, the gradient in our atmosphere. It's well known and understood, and I don't understand the problem.
Which means it's contained, bro. Because we can demonstrate a gradient that is contained. You cannot demonstrate a gradient non-contained, bro. You can't demonstrate the pressure to begin with.
That leads me to say, show me the container.
Well, you have to have a container to have gas.
No, this is where I wanted to go with Rumpus. Can I please make my point, please? Okay, you ready, Howard?
Come on. Yeah, Travis.
You ready?
Yep.
Go outside. Go outside. That's the proof, bro.
Yeah. Yeah.
Yep,
I agree.
Gas pressure, therefore there's a container.
It's the same fucking proof that Rumpus had. Okay, you go outside. That's our proof. Rumpus says go outside.
No, there's actually reasoning behind it.
Hold on, James. Please.
It's not the same.
Yeah, exactly. Please, James, shut up. Okay, I apologize. Listen, I have been trying to get this point in for over 10 minutes. Okay, listen very carefully, please. This is where the argument breaks down. This is where we both arrive at 0 and we still have the burden, okay? If we say to Rumpus, prove to us that, that you have atmosphere sticking to the earth, he goes, go outside. We say, well, just for the sake of argument, there's a container. And he says, where's your proof? We say, go outside. Now, have we demonstrated anything? No. So we have not either demonstrated anything. We've just simply argued in a circle. Okay, so we're both in the same position. We still have not demonstrated anything. We've just simply had an observation. Okay?
That's
This could
not
have been
true,
over
Foley.
10 minutes ago.
No.
That's not
not
true.
true.
We can demonstrate
Yeah,
the
that's not
gradient
true,
because we do
in
demonstrate it.
containment.
Sorry, can I make something?
I'm talking about the atmosphere issue, not gas.
Yeah, you're right about that. Yeah, but the point is
Yeah.
we can demonstrate a gradient under containment two different ways, just a tall pipe or a hot and cold pipe. They can't demonstrate a gradient, much less pressure, period, without containment. We can, they can't.
But it's there in the atmosphere.
What's the difference
What's there in
between
the
atmosphere
atmosphere?
and what gas? Sorry, what's the difference between atmosphere and what
They
gas
use
does?
a barometer in the atmosphere to measure pressure.
Yeah.
PSI, pounds per square inch.
Yeah.
There's logical reasoning to say, go outside, you have gas pressure, therefore there's a container. It's different. They have no logical reasoning.
The only way that you can keep gas there in the first place is to physically keep it there with the boundary that's containing the gas surrounding it. If you expand the container, the gas is going to, expand into that bigger volume that the container's allowed. If you remove the container, the gas is going to go away into the next available space. If the available space outside is of a much lower environment, like a vacuum. So if you can keep expanding the container, the gas will always fill the container. Remove the container and the gas is going to go away. It's as simple as that. That's all I can demonstrate to you.
If I
That
have
claim
a
is the
question.
gas.
Oh,
That just doesn't apply. Go ahead, Brandon.
all right. Here's my question. I honestly don't know the answer. So
It
if I
does
have
apply.
a vacuum chamber and I put a scale on the bottom of the vacuum chamber, I put the lid on, and then I suck the air out, is the scale going to show that there is less weight on the scale?
Yes.
When I suck the air out?
Yes. Yes.
It's scale, on the floor, so
Yeah.
only measuring the pressure vector down. What about a scale on the ceiling of the container? Because the gas is also pressing upwards. If you were to make a reading of the pressing upwards, would that be weight? No, it's the gas pressing, not weight.
Okay, so it would show something,
No, he's
but
saying
it will
if you
show
take the
something
gas
on
out.
all surfaces, not just downwards. Would it have the same reading for all directions as far as the pressure?
Yes, it would. They like to say a helium balloon in a vacuum chamber sinks, but A, it's not a vacuum chamber. B, the balloon is still blown up in all directions. It's not heavier toward the bottom. So that argument
It
they
is.
try and throw is null.
It's not an argument. You put a helium balloon inside a vacuum chamber, it floats. You evacuate the vacuum chamber, the balloon goes to the floor. It's that simple.
Howard, that's because that's because helium is denser than nothing, but the balloon is still blown up in all directions, Howard. It's not thick
Yeah,
like
exactly.
bro.
Exactly. But and it's gravity that causes that, because helium has mass. It's just lighter than
You
air.
didn't hear me. The balloon is still blown up in all directions equally.
It doesn't
Howard.
matter. That doesn't matter.
Hey, what do you mean it doesn't matter?
It still has weight. It has weight.
Can I just say, Howard, Globebusters Bob had a good presentation. I
Well,
think
if the
actually Good Times for All did it. It's only 15 minutes or so on incoherent electric acceleration, and it will explain to you what they are using to call gravity.
They won't give up their downward bias.
And it's a sideways,
There
incoherent
is-
argument.
It's not
If the
just one
pressure
thing or the
outside the
other.
balloon
It's both
exceeds
together.
the pressure in,
It-
it will
yeah,
not expand.
a helium balloon's mass and weight has nothing to do with electricity.
No, all I was saying that
Hey.
is if the pressure outside the balloon is greater than the pressure you can put in it, it will not expand. It must be less than the pressure.
Well, that's pressure differentials. That's a little bit different subject.
Well,
I mean,
pressure.
if you
There's pressure in the balloon and outside of it.
yeah, it's pressure differential. That's just like gauge pressure at absolute zero. You know, your air pressure that you air your car tire up with is preset at 0 with consideration to the atmospheric pressure.
Yeah, it's at 14.7 actually. Yeah.
Right.
But what is that 14.7 psi bit? What's that all about?
That's what the atmosphere. That's the atmospheric pressure at sea level.
Yeah, psi, right? Pounds per square inch.
Pounds per square inch at any point that you put a measuring device anywhere in the atmosphere, out in front of you and behind you, above you, below you, it's going to register that pound per square inch of force.
Inside.
So wherever or whatever the container is, that's the amount of pressure being exerted on.
Well, I mean, if you wanted to think about it, your skin is a container that keeps the inside in and the outside out, but it is experiencing the pressure on the outside of it.
It comes down to this, man. All the gas
I'm
is
just getting
produced
to
at
the
ground
fact
level.
that
And all
I'm
that
just getting
gas
to the
is
fact-
working its way up like 20 miles high. Even though it's being produced and cycled down here at ground level, there's got to be containment somewhere for it to even get up there at all. Okay, to have pressure in the first place, there has to be containment, period, dude. Some kind of
Well,
containment.
I understand.
You want to call it
I
gravity? And I'd like to see a demonstration of that. That's all. All we're asking for is a demonstration. We can show you a gradient, a pressure-contained gradient, but you can't show us one without saying look outside, and we can say the same thing, look outside. The point is the gas produced at ground level makes it all the way up, miles and miles and miles up in the atmosphere, and there's got to be some barrier up there, and it's the same thing as the helium balloon dropped in liquid nitrogen. It just deflates completely. The air's still in there, right?
Can
But
I
it
give
just
an
deflates.
example when you're finished?
Yeah, I'm done.
You know when you rub a balloon on your head, like when you got static electricity in your body and your hair starts to float?
Yep.
Depending on how much static electricity, this is why the gases layer themselves in the layers they say they do. You know, helium goes up highest.
Density, man.
No.
It's not just density, because the Earth is a negative plane. We must be in between two electric plates where the negatives on the bottom, positives on the top, and the gradient just goes from the ground all the way up.
Yeah, we might be.
So when you jump in the air, the static electricity, that force is being added to you as you go higher. So then it's trying to push you back down, pull you back to the negative.
You got to admit, I say it could be there. It is a negative charge down low, and we get a potential up high. But as far as it being a force,
that's the ionosphere, darling.
Wait, let me finish. Everything orders itself according to relative density, and that's the only thing.
That's why I said both. Yeah, no, we can prove electrostatics can change the vector. You can prove that. I can demonstrate that.
Well, you know,
but you can't demonstrate something.
when you rub a
I can't demonstrate what?
You can't demonstrate something disobeying relative density.
Disobeying relative density. Okay. All right. I'll have a look into that. No worries. So you want me to see if I can make electrostatics cause Sleeping Warrior's egg to go the other way? Is that what you mean?
Yeah, that's the way everything operates on its density and what it's relative to. But
I'm just saying that the electrostatic might give
I understand the argument. I do understand the argument.
It might just be what is making up and down. Like the electrostatic force might just be how the creator set up and down.
I'd buy that.
That's all I'm saying.
Could be, and as long if you have to have a force, that's how I'd go. But to me, there doesn't have to be a downward force at all.
Yeah, and then your relative density disequilibrium.
That'd be a better way to explain it. I would agree with that. But to me, you don't need a force. There's no force. Things go where they're supposed to be. That's my opinion.
The problem is that I don't think one's needed, but I'm sure it's there. We can see it's there. You know, just by rubbing a balloon on your hair and lifting it away, your hair will float. Or I've seen people have their hair go up, you know, floating in the air even without anything being rubbed on them. They put this static electric charge into them and your hair starts to float. So, you know, it definitely can cause things to change direction and do funny things.
I see Bearded Devil in the
Yeah, it's
chat.
kinda
I'm going
funny
to
how-
say something that I don't think is expected to come out of my mouth, but I saw some pretty good demonstrations from him on Jose's show. I think it was yesterday. And he's more than welcome to bring them in here and show us his demonstrations at the risk of falling into his Socratic trap. But I have that video on screen, that how incoherent electrostatic acceleration creates the downward vector, very literally titled.
Awesome.
And I
A
put
guy in the video uses the force to point his finger at these candles, and he's like a meter away from them. And as he points his finger at it, the candles start to go out. He moves his finger along the line of candles, and they all just blow out from this static electricity that's coming out of his body.
Well, it's pretty amazing. So save that link, everybody. Watch it later. Don't go watch it now. You don't want to miss the rest of the show. Save it.
No, don't watch it.
Mic test, is this okay?
Yeah, go ahead, Jimbo. You were trying to get in there for a while. Go ahead.
Okay. When you rub a balloon, you can stick it to the ceiling or to the walls. So this directionality or this force is omnidirectional.
Absolutely. Yeah. You can make things go up, down. You can do all kinds of things just by increasing or decreasing the static in the object, or
You're not
the air
supposed to
around the
know-
object.
You're not supposed to notice that.
I will say this, though. I will say this.
I'm not supposed to say
I
there.
will say this. Like when we were talking. Sorry, go ahead, Jimbo. I'm sorry. Go ahead.
Yeah, I'm not supposed to say there is a down, but with mass and dead weights, there is a down. Weights produce stress or strain downward normally, and strain is measured with a gauge called the strain gauge, So strain gauges convert stress or strain into, well, the units that we use for mass and weight.
Yeah, but they're calling us down, us being on the ground. They're calling that 1G. That's bullshit, man. And they call something falling.
Yeah, that's bullshit.
0G. To me, something on the ground ain't no 1G. Something on the ground is equilibrium. It's at equilibrium. Something falling is not in equilibrium. It's in disequilibrium. That's the trick, man. And that's what they're buying into. It's a freaking trick, man. But if there is going to be a force or a bias, that would be the one I buy to, because I will say this, and I'll try to make it quick. And this relates to Bearded Devil. When I was talking about Blue's Cavendish experiment, he's talking about the lead balls, and at first I thought he meant just the big balls had a ground wire on them, but he did confirm that both sets of balls, all four, have grounding wires. But then I told him that still I'd like to see different material to make it an experiment, more of an experiment, and he might be game for that. But I showed him that you could take two lead plates, okay, and you could put them together with a separator, and put them close together. Two lead plates, not charged, no lead dioxide, just pure lead plates. Put them together and separate them with a cloth or something. Before you even put electrolyte or anything like that, you put a meter on them. One is assumed positive and one is assumed negative. Well, opposites do attract. And I showed that with just in air, and he said the gap is like a couple inches or less between the two balls. So it has to have something to do with electromagnetism, maybe not so much as the statics. And the Cavendish is the same apparatus that they come up with Coulomb's law and the value of 1 amp, Coulomb. And
Coulomb came up with Coulomb's law. They didn't. Like Ampere
but it's the
came
same
out with the
apparatus.
Ampere.
The Cavendish is the same apparatus that Coulomb used with the lead balls and shit. And I told him to use something besides lead because it's interactive. I showed them where if you just take two identical
Coulomb
plates
didn't
and
use
put them
lead
together,
balls.
one assumes positive and one assumes negative. I demonstrated it, and Bearded Devil said, show it. I don't believe that, show it. I showed it live on Jose's earlier today, and he still wouldn't shut up. He still questioning me with dumb shit. But yeah, I'll behave if he comes on.
Yeah, basically all he did too with the balls and electricity was show that like charges repel and unlike charges attract.
Right, but when you take two lead plates and you get them close together, one assumes positive and one assumes negative. It's natural. They're very
Understandably, Lead, although it seems almost like weird metal, it still has a crystal structure. It forms lattice.
I know you know
These
all about
lattice
this,
form
Jimbo.
polarities, north and south poles.
Yeah, I know you know all about this, probably more than me, but I do notice what I've shown, and that's why I said if you put them close together and without no electrolyte at all, one assumes positive, one assumes negative, that could be an answer of why they attract. And then another guy said they've used all kinds of materials in Cavendish and bowling balls and all that. I said, yeah, but I ain't seen nothing like blues built with any other materials, and I'd still like to see it. I told Blue, I was like, man, you might be able to win a prize, a Nobel Prize or something, if you could, let go of your model and try and prove the mechanism behind gravity, if there is a mechanism, if mass does attract mass, because we don't observe that in nature.
That's the thing. There's no observations of this mass attracting mass that would lead to that experiment. And I'd like to see it in a different way too, Cavendish. That was one of the points I brought up in my video when I talked about it is, well, separate them, separate the masses, have them be non-diamagnetic material, put them at a great distance, show us at a great distance. You're relying on this very close quarter elaborate setup that measure a force that is equivalent to the weight of a third of a grain of salt. And then applying it to the whole universe. It's ridiculous. You got to show us more than that.
But when y'all, to me, and just expressing, but when y'all say show me mass attracting mass, to me, everything that y'all call as an equilibrium is an example of mass attracting mass.
No, it's not. Okay.
Well, then you should be able to manipulate it and show us you're doing something different.
But you know what? You talk about manipulating it. When that can be done,
yeah,
our whole paradigm's going to change. Because
what do you mean when we can do that though? We're doing it. We're trying to show you, and you're just going, no.
No, you're not manipulating.
I still believe in gravity.
You're not manipulating.
Yeah, we can manipulate the electrostatic forces. We can manipulate the density of the mediums. Change. Sleeping Warrior did it.
Gravity.
Zach has done it.
Yeah, that's not manipulating
what
gravity.
Are we not doing? What are we not manipulating, Howard?
He could have cooled the water down and got the same result.
You can change fluid densities and change buoyancy values and things like that.
Hang on, don't go off on something else. Tell me why you said we are not demonstrating anything.
I didn't say that. I said
you're not demonstrating gravity.
You're not manipulating gravity.
Yeah, because you can't.
We're not
testing
manipulate gravity. It's your fucking job. You're supposed to be showing gravity and manipulating it and showing us that it works. We're saying it's not gravity, it's relative density disequilibrium and maybe a little bit of electrostatics causing an up and a down, setting the up and down. And then everything else is worked out with your relative density disequilibrium. We have shown you tests, we've done experiments, we've manipulated the cause of our effect, and you still, nuh-uh.
Besides using the scientific, hold on a second. To add to her point, using the scientific method, how do you even manipulate something you cannot observe?
That's right. Well, I mean, you can.
In other words, how do you know you're manipulating?
You can't turn it on and off. Is what I'm talking about.
You can't even vary or manipulate it. You just skip that method and still call it science. You can't observe it. You can't vary it. You can't isolate it, manipulate, control it.
No one's ever claimed to manipulate gravity.
It's not gravity.
Exactly. So that's why we're saying it's bullshit, because nobody's done anything scientific with it.
That's because you're listening.
Still call it science.
That's because you're listening to QE. The science and the science
when I've got demonstrations,
entire books written on
scientific demonstrations on our side, and you've got nobody's manipulated gravity. Nobody said they had on your side.
To gravity.
What the
because
fuck
we have
are
a
we
substance
supposed to
to
believe?
manipulate. Gravity is no substance. At least electromagnetism appears to have a fiery blue substance that's a bit more manipulable. Gravity does not. So electromagnetism is a superior philosophy. So let's go with electromagnetism.
That's all I'm saying. No one's ever turned gravity on and
You
off.
can vary and
That still
manipulate it.
says you need a force, though, Lemon. You need a force, and the force is lifting something up. We can say, yeah, once you lift something up, once you lift the solid up in a air, oxygen, or whatever regular air medium, then you can calculate that things fall at 9.8 meters per second squared. It's when they start talking off-planet shit and they start saying M1 times M2 over R squared with the big G. It's like that is never going to be demonstrated. And we can
That is
come up with
demonstrated.
calculations, man. But
and
that's
that
not
is
the
demonstrated.
force. The force is bringing something out of equilibrium. Taking something out of equilibrium is what requires the force, guys.
We
Because
we might be able to prove the firmament looking into electrostatics because of the way that the gradient of the electrics works. There must be a solid plate of some kind above us as a positive for the Earth to be a negative, and for these effects to happen. That is what must be there. What they did was they changed what they said the electrostatic forces do, and said that it can be the ionosphere, just a gaseous, thing that you can go through. But that's not true. Before that, they all agreed that it would have to be a solid thing with a positive electrostatic charge.
The field shape, and that would tend to be a solid structure to make the Earth like a battery if it is electromagnetic. Yes.
Mm-hmm.
The Earth would be one, possible terminal. The firmament dome would be the other one.
Hey, I will agree with it in one way.
The reason why
If there was a limit,
so
if there was a limit before that dome or whatever, if there was just a limit up there, like the ionosphere, or like say 50 miles up, or 40, 20, 30, 60, 100, if we got past that rise in electric potential, then it could be possible to reach a type of medium where things could be weightless.
Well, I think that there is a solid firmament, but it would be highly electric, in this sort of paradigm. So I think that God in his wisdom would have made, some sort of buffer zone to kind of keep us from touching the thing. It could be a thicker, bit of, ether, waters above or whatever, some sort of buffer layer to keep you from touching the thing. And that kind of reminds me of that rocket that appeared to hit something without exploding. Like it just stopped suddenly, like boop, like it hit some sort of buffer layer. So maybe there's a buffer layer before the dome.
Superfluid, man. Superfluid makes sense, and it even if it was
does,
superfluid
doesn't
up there, it'd be like throwing something cold in a pot of boiling water. How it just blasts off. In my mind, I picture something super quiet, and if you were to heat something up, it would just repel you super fast opposite the heat. And it would be quiet.
I
It'd
love
be like
the
it'd let sparks
speculation.
down. In my mind, it would let it'd be super quiet, and it would let sparks down, maybe a plume or something like we see, kind of. And it could propel us, man. But who
That
knows,
might make
man?
the sprites.
We're speculating now, though, man.
yeah, I got a question, and maybe it's because I need some serious help here. The reason things fall down. All right, we live in the medium of air. And just about everything we see, touch, is more dense. It's going to fall through that medium, right? If we lived in the medium of water, and let's just say our lungs was 3 times as big, right? We'd be going up, and just about everything else would be going up as well. So then you would say there's gravity upwards. But it's all based on the medium that you're in, and you as the variable,
I agree with
or
that.
whatever
That's
you
all we
vary.
can prove.
Yeah, it's simple, because if you change the medium and the result changes, then obviously you found your cause.
And
Now,
the
you
only
might have
force
some.
is taking something out of equilibrium. The force is applied to get something out of equilibrium, and then it'll go back to equilibrium naturally. We're just giving it potential energy, right?
Well, you could you don't even have to pick it up. You could pour certain liquids into they call the density tower, put your variables at the bottom. Once you get your liquids in, they're going to go up and down, or just stay where they're at, obviously, if they go down, according to their density or equilibrium.
You're describing buoyancy.
Yeah, but that's the cause and effect. That's over and over, the same result. Boom. Boom.
Yeah.
Oh,
So
You're
no.
kind
And
of
we don't really
buoyancy,
need to appeal to gravity either to.
you have to add the equation. If you're going to have a downward force, you have to have a buoyancy equation
No.
that uses the downward force, 9.8 meters per second squared. You have to
Why
have
do you
that.
have to use
and you have
that
to have
equation?
another equation.
Why do you have to
when
use it?
when that's not the way nature acts, dude. Nature acts in
Yeah, it is.
equilibrium. It's down or up. It's relative, man. And the way they
Gravity
describe
is not
gravity is not like
necessary.
anything
You
else.
get
yes, it
horizontal
is.
movement. You get left to right horizontal movement as well.
Gravity
As
is
things
not
go up or down.
necessary if there is a medium present. It is made to explain why we have a vacuum of space with no medium and this sort of behavior that's occurring, but perhaps there's still a medium present in the vacuum, like, you know, the electromagnetic background, the ether, or whatever. Maybe they were a little too hasty when they said that there is no medium in the vacuum of space.
So can you calculate buoyancy without gravity?
No.
Just take out a stopwatch. You're acting like gravity is a substance that you have to add.
You don't
I mean, all you have to
need
do is take out the
buoyancy.
stopwatch.
We can
That's
do it
it.
without
There's no such
your
thing as
gravity,
buoyancy. Everything is
Howard.
relative.
The way that you define it.
I'm saying you don't need buoyancy. You don't need it. All you need is the variable and the medium.
If you build a big old steel battleship, you better accommodate buoyancy, or it ain't gonna float.
No, all you're doing is changing and releasing the medium.
That's not
That's what
true.
you're doing to sink. Yeah, that's what you're doing. The medium in the tanks. You
How
add
do you
water
think
to
a submarine sinks?
You add air to go up. That's the only
ballast
thing you're
tanks, you
changing.
either fill them,
That's the cause
with
of
medium
the effect.
or empty it. Jeez, how could you say that that's not what?
Call
Howard,
a
like, what do you?
shipbuilder and see call a shipbuilder and ask them if they use buoyancy in their engineering.
Of course,
Why
but
would
what
they?
are they
They could
doing?
claim anything. They don't need it.
Yeah,
They're
but
not
what are they
using the
actually
force
doing
impulse.
when they do that?
They're not using the force impulse at the center of the earth. They're
You don't
pulling
do a
the stopwatch
scientific
and timing how
experiment.
long it takes to move
Observe
through the
everything
medium.
in it.
So all you have
They
to do
don't
is watch
observe.
the stopwatch and see how long it takes to ascend or descend through the medium you're talking about, be it air, water, ether, or whatever. Just pull out your stopwatch. You don't need a force that's pulling to the center of the earth.
You can't.
Yeah, you don't do a
calculate
scientific experiment. Hold on. You do not do a scientific experiment. Collect all the data, all the variables, control it all. You don't go through all that just to insert something that you have no clue about, no scientific knowledge about whatsoever. You don't just insert.
What
You don't even need it. Everything
What
else
are you
told you
saying?
what's
There's
going
no
on.
scientific. What do you mean no scientific knowledge about?
Gravity.
Yeah.
There's no scientific knowledge
You
of
deny
gravity.
that. You deny that, but you're so wrong, Matt.
Well, what scientific
asking you
experiment
for
do
your
you have
scientific
about
evidence. You're
gravity,
saying
where you
don't
define it
tell me
as
any
pulling
scientific-
towards the
it.
center of the Earth?
You
and,
admitted it.
and all that shit, space-time bending. Why do we need that?
Yeah,
Why do
your
we
first
need all
step
that
of the
story,
method is
Howard?
observation. Show me gravity.
We don't have to talk about space time because and space time bending, because that's way out of our realm of expertise. I don't understand it, and we can use
Oh my
Newtonian.
God! Well, that's
Well,
their
we can use
rhetoric.
Newtonian physics.
Well, let him finish, guys. Let him finish.
Well, we could use Newtonian gravity to do just about anything that we need to do here on Earth. This in engineering, even orbital mechanics, just uses Newtonian physics.
Okay, then let's take out our stopwatch and see how long it takes to ascend or descend through the medium that we're talking about, and junk gravity, and not assume that there's a vacuum in space. How about that?
You do that, Lemon. I want you to record it, and I want you to perform the experiment and calculate the buoyant force and come up with the numbers.
Can I set a bit of a brain teaser? Can I set
Why
a
on
brain
earth are we trying to prove your model? You're supposed to be doing that.
No,
We're
he's
saying it
not.
doesn't exist. You don't need it.
I asked Lemon to prove what he just said. I didn't. I'm not
Then
the one
why
that
would
made
he ever need to prove buoyancy math? If he's proving what he thinks, why would he
That's
ever
the
need to
dodge
prove
of the-
buoyancy math?
That's a dodge of the century. It's
That's
like
your
he's the one
job,
that made-
Howard.
He made the
It's
made
your
the claim.
belief.
Look, the
He
brain-
made the claim.
Bullshit! He's not
don't.
claiming gravity or
They
buoyancy
don't
at
care
all.
what buoyancy
Okay,
says. They know they let a certain
Fuck
amount of
me.
water in, it goes down.
We could do this, but it's going to take some math. But okay, I assume that there is an electromagnetic background, aka the ether, that is ever present. I will see if I can find anybody who's done some math. In fact, there are a couple people that have done some math on the ether with dissonant math, dissonant science. I'll see if I can find the video, but it was pretty interesting.
The
Can I
Boyne
set a
equation
bit
has
of
a
a brain
negative in it to
teaser?
begin with. The Boyne equation has a negative in it. That should be a hint.
Can I set a brain teaser?
Yeah, go ahead,
Hold
Brian.
on.
Mabbott, go ahead.
I've
Yeah, Brian.
posted the density tower in the chat there, and the middle one there is milk. Can everybody see that? Milk is in the middle. So if we have a syringe, and say a 50 ml syringe, and we inject some milk onto the top, what would we expect it to do?
Fall down till it hits that equilibrium.
That's right. So now if we put a piece of tube on the syringe, go through all the layers and inject it into the bottom layer, what would we expect the milk to do?
Go up.
Go up till it's equilibrium. And you could do the same thing with air, and it would go up through all of them. And that's the
And
medium we live in.
That is equilibrium. It would go to its point of equilibrium within that gradient.
The only things we have changed is the density of the medium we are injecting the milk into. No gravity change. We're changing the medium that we're putting the milk into. So if we go below the milk, it'll go up. If we come above the milk, it will go down. It's finding its density level in that tower.
That is,
I like what you did there. This is why I like to use the air, because if you inject air at the bottom of it, the air will go up through all of them, and that's the medium we live in.
Yeah.
They say that the average cumulus cloud weighs over 1 million tons. The average cumulus cloud. You have over 1 million tons of water in an average big ass cumulus cloud. And how are you saying that you have tons when it's floating in midair? It's because everything acts according to its surroundings.
Because water, and I always had that same question, and it was puzzling to me. But the water molecule, H2O, is less massive than a nitrogen molecule, and that's why clouds float.
Well, we can create clouds.
Clouds have just found their density level. That's why they've all got flat bottoms. That is their density level. And it shows you we have layers in our atmosphere.
Yeah, exactly.
Easy as that. It's absolute piece of piss. They've turned it and twisted it and fucking come up with all these equations. Complete load of bollocks.
It's not.
You could build a greenhouse. You could build a greenhouse, and as you're walking through it, you can see like the air. It's not like clouds we see like we're talking now, but for the size that the greenhouse is, you can like see little pockets of thicker air or clouds, I guess you could say, right?
It's no more than what we see outside with different layers of clouds. We see cumulus clouds, don't we, right up 10,000 feet high? They're obviously of a lower density than the ones that are down at 3,000 or 4,000 feet.
But what
causes? If you are going to build a greenhouse, what do you have to build?
What causes
it to rise or fall? I'd say vibration and frequency. Everything vibrates up and or down to its level.
You got to build a container. Build a greenhouse.
Wait, let Howard respond. I think he was trying to respond.
Yeah, I was just saying, what creates that density layer? What causes the heavy shit to be on the bottom?
That's the open question.
Nature, equilibrium.
Equilibrium. It
Think
can't
about
pass
it.
through the ground.
You take the Boyne
Equilibrium
equation,
is not an answer. That's a
F
non-answer.
point force. FB
The
equals
glass.
negative PBG, okay? The P is the freaking fluid. That's one of the only equations you see negative in. I understand that it was way easier to just take what normally happens, and then they had to also do specific gravity because to explain all the other shit. But it was way easier for them to just say, okay, most things that we measure fall in air and they're solid.
But see,
okay,
but see, here's an example that the best I can come up with, and I'm always trying to think of what is a good example. You can take like say you've got a density column with 6 different fluids in it, and they're all arranged, the column I'm talking about. But you can take those 6 fluids individually, calculate their density, and you can predict how they're going to stack in that density column based on their density. And the heaviest will be on the bottom. And gravity is the answer.
Heaviest will be
Not
on
with
the bottom.
force, you can't. You need specific gravity then. You need relative density then when you want to get that specific. That's why they call it specific gravity. My point, Howard, is it's easier to just equate everything that's going to floating up in water to say it's negative gravity, and gravity being everything solid falling in air. But they're looking past the fact that if it takes more force to lift something heavier up in the air out of equilibrium, okay, and they attribute that force to mass, which is unnecessary unless you leave the planet, man. The weight doesn't need to be attributed to mass unless you leave the planet.
So you've said that 2 or 3 times. It takes a force to get it out of equilibrium. What does that say?
Well, it's in the medium of air, right? So that's why all the liquids are falling through it in the tower. But once it hits the bottom of the tower, it's hitting the glass.
Not a force, Howard. Pressure.
So that's another point. If only due to relative density, we would all weigh 14.7 psi.
What?
That's not true.
No.
Crazy, man.
No.
Well, that's the only thing. That's the only thing. That's the only thing. If your medium is pushing on you,
then you have to start assuming that. If you start thinking outside of a planet, then you have to assume that, bro. But if you're operating on the grounds that what goes up must come down, or to take a beach ball underwater, it takes force to get it out of equilibrium. One thing I know from my years on Earth is that nature works in equilibrium.
Yeah,
you would have to do that the other way, wouldn't you? Whatever you weigh, you deduct 14.7. It wouldn't be the way you're saying.
If it requires a force to pick it up, then you're opposing a force that's keeping it there.
Is the force from the center of the Earth and/or from the background electromagnetic medium, though?
What's not to say it's stacked up from the top downwards as opposed from the heaviest upwards?
That was a
You got
good one,
air,
Larry.
guys. Look at the density tower. So in reality, we have air, and then we have the ground. Now, if you just poured those liquids out on the ground, they're going to go into the dirt. The experiment's not going to work. You need that container to do that experiment, right? And you can see what happens with the liquids by doing it that way. So I don't see why you're saying, why is the denser one on the bottom? It's because it's not going through the glass. It's not going through the dirt.
Bottom. It's in the bottom because it weighs more.
But dirt is a medium, and that's what's under our feet. It is a medium.
Dirt is. Yeah.
So it's the more denser one of the tower. It's still going to go through it till it soaks it all up. But it's not. It's a dense. It's still a medium dirt. Matter of fact, when you put utilities underground, you got to know what dirt you're in.
Into solid.
You just cut out, Howard? Did we lose Howard?
I can't hear him, but it's not too much to think that we're in some sort of invisible density tower with the clouds floating overhead. It's not that much of a jump, and it's actually less of a jump than thinking that gravity is this mystic force pulling everything to the center of a ball. So I'm going to go with an invisible background medium of some sort, deciding what floats, sinks, or rises, probably based off of its level of frequency and vibration, vibrating up, vibrating down, whatever.
Okay, just real quick. Remember that Howard said earlier that gravity cannot be turned on or off. So then it is a null variable. It's never taken into consideration. So this is all a moot discussion.
Great point. And he did say that.
Okay.
Yeah, let's remember that big G has nothing to do with anything on Earth unless you want to make it mean something. It's that big G is the F versus the gravitational constant, like 10 to the the gravitational constant, whatever the hell it is, 10 times negative freaking 16 to the 30th bullshit. That's that they equate that to figure out the weight of planets and the orbits and our weight on the moon and shit. Just the little g is just 9.8 meters per second squared, or per second. So little g is just a measurement of what we observe, and buoyancy is a negative reading of that based on the volume, the amount of the fluid volume. And it's one of the only negative equations I've found. And I think when you start seeing something stick out like a sore thumb, then it's probably a simplification of what's really going on, in my opinion. That's it.
So why are you trying to determine what happens out here in the medium we live in when doing your experiments in the vacuum? Because when you take all the gases out of a chamber, whatever you want to call it, container, you're changing the medium. And we don't live in that medium.
Yeah, I think they're full of shit. I think if you take
so why would you get that equation 19 something point meters per second in a vacuum and then claim that's what's happening out here? I don't understand that.
Well, you can't ignore that the electrostatics is stronger than so-called gravity
but
as well.
things don't even fall at the same rate like that, man. I showed that in my very first video on my channel, Flat Earth Test. I drop a golf ball to ping pong. They said the only difference would be the wind resistance. I picked two objects the same damn size to have the same damn wind resistance. They don't fall nowhere near the same rate. And then what they say, well, the ping pong ball's lighter. I said exactly. The ping pong ball's lighter. Exactly.
Well, basically, they're
but so you're doing this in a vacuum, and you're trying to equate it to what's in reality, and you just admitted in reality that doesn't happen.
Well, the thing is, they're implying by their actions that the purest forces are in the vacuum. They're thinking that there's no other force, no air, no
live in a vacuum.
Offer a medium in a vacuum. They're mistaken. There's still something there. So they're close.
And it requires a container.
What's he putting in a vacuum?
There's always something there.
A bowling ball and a feather.
No. I was talking about my golf ball, my ping pong ball. They fall at obvious different rates, and the closer you get to the medium, the more it starts becoming obvious that shit falls at different rates. If you take two planks of steel in water, they're going to fall at the same damn rate. But if you take something a little more close to the buoyancy of water and a piece of steel, then they're going to fall at way different rates. Same thing with air. If you get a couple things that are close to the relative density of air, they're going to fall at obvious different rates, man. They don't teach us this stuff, man. It's things we got to deduce logically.
It's like dropping
tests of our own.
Yeah, there's a lot. There's different variables.
It's like doing the experiment
in
water.
Something falls. The shape of it, that kind of thing, right? What medium it's in. So it would be interesting if someone could come up with some calculations that don't rely on their gravity. Just say, here, this covers all the observations. Just take the observations that we have and create some calculations that don't require their model of gravity.
It's complicated though, Brandon. That's what I've been trying to work on. But the thing is why not go off what we observe? And we observe shit falling at 9.8 meters per second. But we got to figure out a way to get rid of the negative buoyancy and everything. It's way more complicated. The reason they did it, when you try and do the equation, like you're saying, Brandon, you realize why they did it, how they did it. It's way easier. Same thing with angles of the sun and 15 degrees per hour. It's just so much freaking easier to do it like that, man. They might think that the flat Earth model is Stone Age, but it's way more complicated to do shit the way it really is.
Yeah.
Right there, Brandon.
But you're saying, hold on, this is what you're saying, dude. I can't let you escape this because the 19.8 whatever meters per second, that's done in a vacuum.
Yeah, we know.
That's not done in the world we live in, right?
No,
so that's like doing that same. Hold on. That's like doing that same experiment in water or mercury, and then claiming that's what's happening here.
Yeah.
Right,
It's just an approximation. They use it as a shorthand.
And none of them, Yeah, and none of them fall at the same rate either. And they say that everything falls at 9 point. I'm just saying approximation, and they don't even fall at the same rate. We've seen other channels demonstrate different elements in a vacuum fall at different rates. But I'm just saying to do something basic, that's what they come up with. It was something that we observed, something approximate to what
I
we
got
observed,
you.
and to go
I
off
got
that.
you.
That's what I'm trying to say. It's a simple form to make everything
Sorry,
relate. And
that's
then
nonsense.
they do buoyancy because they say everything is pretty much buoyant in water, right? But you go past that, then you need specific gravity. That's when it starts getting more complicated. So they haven't intertwined all the forces together, man. It'd be a pain in the ass, and most people wouldn't understand it if they could come up with it, man. It's just so complicated because there's so many different elements and melting points and all that, so that's what I'm saying. The globe model is just so much easier to understand, and they've made it work, and that's the only thing I'll give them.
It's a good
What about
mathematical
sound?
model, but Phil, you had something to say?
Okay, so what I was saying was that everything does fall at the same rate in the same gravitational field. The difference is that things that are different sizes, for instance, and different densities will be affected differently by other forces. So it's other forces such as the air, the atmosphere that's acting on these objects, and that's why they can fall at different rates in the atmosphere.
Have you ever tested that, Phil?
But of course, in a vacuum cleaner, in a vacuum though, there aren't these forces around, so everything does fall at the same rate in a vacuum. That's the whole point. That's why these things are measured in a vacuum, so that we can get an extremely accurate reading. Now, if you take two things
a helium balloon and a balloon full of carbon dioxide will not fall at the same rate in a vacuum. It needs to be something close to its medium.
Yes,
I've
they
experimented
will.
around
In a
in this,
vacuum-
not with that in a vacuum, but I'm just saying. What I'm saying is, the experiment I did in the 6th grade was that things fall, solids fall at the same rate. Okay, and the only difference is the air resistance. And the fact that the golf ball fell faster than the ping pong ball, they said that because the dimples are on the golf ball. So I grinded the dimples off the golf ball, and it made no difference at all. And they're the same size with the same air resistance, Phil.
No, if you drop a balloon and of helium and one of whatever gas you like
Lead.
in a vacuum, they will fall at the same rate. That's the point. There's no other forces acting on it. Okay?
No, they won't.
That's
You
the
didn't see that
point.
video where they did
That's
7
the
different
point,
elements,
dude.
and they all fall at different rates in a vacuum, and
You're
they
just
had vacuum
contributing
tubes.
something too.
No, they don't.
Somebody find that video, man. Yeah, they do, man. It's been
No, they
demonstrated.
don't.
Let me
I'm
find it
sorry,
real quick.
they don't.
No, they don't.
They don't.
No, they don't.
Okay, this has been known since all the way since Galileo. For goodness sake, this is not something new. Okay,
Just
you
'cause
can
you ain't
actually
seen it don't mean it ain't happened, buddy.
You can actually prove this with Archimedes' principle. I can prove it to you. I
Can
prove
it be a
This
vacuum?
only happens.
mathematically.
Can it be
I can
classed
prove
as a
it.
vacuum if there is gas in there?
I
You're
can
not
prove
getting
it to
my
you both
point.
physically
My point
and
is that it
mathematically.
only happens in a vacuum. That is my point. This only occurs in a vacuum.
Due to the
We
atmosphere
don't
that
live. We do not live in a vacuum.
Outside of a vacuum.
So what does that mean?
Vacuum, there are other forces.
That means
We don't
that
live
means
in a
you
vacuum.
change
What
the
does that mean?
medium, so you change the result. Yet you're saying that your result is back in the medium you live.
Yeah.
No.
We're talking about
That's what you're
the
saying.
gravitational field. We're not talking about the medium. We're talking about the gravitational field.
No, you're not talking about no
the
gravitational
medium,
field. You're
because the
talking about
medium
how
is the
fast
vacuum.
things fall. That's what you're talking about. How fast
Yeah,
things fall.
how fast things
A
fall.
vacuum is a
Joe,
medium, dude.
It depends on
No.
it depends how you can measure how things fall is remove all the other forces. This is science, okay?
Yeah. Remove
All right?
reality and then
Take-
claim it's
We
reality.
take account of controls in science. All right, that means
Right.
we remove all the other
With a
factors.
container.
We
No, you
move
didn't.
remove the listen for a bit. We remove the other factors like air resistance, like friction.
Yeah.
We remove all of
Yes.
these things. This way, we can measure the acceleration due to gravity on its own
isolated.
objects, and we
No.
It's
find
called
that it's the
controlling
same for
variables.
everything.
No, you're only measuring what occurs in a vacuum and then calling it gravity.
It's called
It
controlling
only
variables.
everything.
occurs in a vacuum.
Well, of course. Don't you understand
Yeah,
that if it's not
that's
in a
my
vacuum,
point.
other forces will apply.
Yeah, reality applies. That's right.
Other
But you're
forces
changing the
will
medium.
apply. Other forces
No,
will
no,
apply
no,
if
no,
it's
no.
not in a vacuum.
No, you're claiming that there's one force that you
This
cannot
is
observe,
not really
isolate,
hard,
vary, or
okay?
manipulate.
I'm
Listen to me. Let me finish.
completely.
But
I'm actually quite.
I know
concerned
what
with
you're
your
saying.
inability to grasp this.
I know exactly what you're saying.
So
No,
if I
you
take
exactly
the
what you're
wheels,
saying.
if I take the
You're
wheels off,
saying that
understand
you're
what
saying
I'm
that when
saying.
you
It's
create,
clear
hold
that you
on, let me
don't.
finish. This is what you're saying. That when you create the medium of a vacuum here on Earth, it takes out all forces except for one.
yeah,
That's what you're saying.
That's right.
No, what it's
And-
doing, and I'm telling you what it's doing. All right?
Yeah.
You're creating a medium in which you'll only get these results, right? And then you're claiming you took out all forces except for this downward vector. But this only happens in a vacuum.
You know why?
So
Because we
hold on. I don't know whether the outside forces would be electromagnetic, all other forces that are kind of invisible but not, we can still see them.
So
When
you're trying to hold on, it's hard for me to say what I'm saying.
Let's
You're
try
trying to put one, right, that you cannot measure here. That's why you need the vacuum. You can't measure here. So you're trying to say that there's a force there that you can't measure here. You need the vacuum, and then apply that force that you're looking for when it could be other forces outside as a factor. So
No.
I let's say I gave you some
It's
sort of
plainly
downward
obvious.
bias.
That's why I said.
Let's
you
just
did
say
not
I gave you the
understand-
downward
That's why
bias.
I said you didn't understand this. Okay, I was.
Yeah, but
correct.
the one thing
again,
I did
Just
understand
be
it.
quiet for a minute. Just be quiet.
The
for a
one thing
minute.
you're attributing it to is something that
just
you
be quiet
cannot
for a minute,
observe,
please.
isolate, vary, manipulate. That's what I'm getting.
Can you just mute yourself for just a minute and listen to what I'm saying?
Hold on, Phil. I just posted
No,
in
because
general,
he's making
I
Hey,
just
let
posted
Phil
in general
respond,
the video with
guys. Let him
Hold on,
respond.
He's making the point you can't address. Bring it back to
Real quick,
Howard.
Phil.
Howard, listen, just real quick. Howard.
No, hold on a minute.
I
Just hold the fuck on. Let Phil respond and finish this little side thing here.
No, he's gonna misdirect.
I don't give a fuck what he's gonna do. Let him finish. Finish your thing, and
Okay.
then we'll move on.
Thank you, Brandon. So what I was saying was that we definitely need the vacuum, and the reason that we need the vacuum is so that we can do some science. We can actually control the other forces, because we
Except
know
for
that there's
gravity.
plenty of other forces.
Except for gravity,
Gravity
the
is
one thing you can't manipulate.
gravity is the only force that's available to us.
You
in
can't
the
turn it
vacuum.
on. You can't turn it off. You can't prove that it's actually a variable.
Hold on, I just went through all the trouble of finding this video, y'all. I posted in general. There's a couple demonstrations of different elements falling in a vacuum. I posted it in general.
All right.
I took the long cut and did the Peter and Pete version, but there's a couple different tests in vacuum tubes that shit does not fall at the same rate.
Pete and Peter Charlatan.
I think I've pretty much
Well, they
covered
mirrored
what
that
I need
part,
to do,
bro.
Brandon.
They
Thank you
mirrored
very
that
much
part.
for listening.
Well, let me respond to what Phil just said there at the end. Is that you are not measuring gravity when you are putting things in a vacuum and timing how they fall. That's not what you're doing. You are
Yes, we are,
measuring
Brandon.
things falling. You are saying it is gravity causing it.
Yes, of course.
Yep.
That's what you're doing.
Okay, Phil,
Yeah,
listen
well,
very
we-
carefully.
yeah,
Phil,
it's
listen,
falling, it's
listen very
accelerating to the
carefully,
ground.
Phil. Phil,
Yes,
listen
Brandon,
listen
just
very
so.
carefully, please. Listen very carefully. How do you know if you can't turn gravity off that the electromagnetism isn't the force? How do you know that
we can measure it?
I can
Okay,
change the gravity.
No, you can't.
I can change that.
Okay, you do. Okay, hold on. Earlier, hold on. earlier, Howard said you can't turn it on and you can't turn it off. And he just said a couple minutes ago, you can't manipulate it. So please,
No, but you
Phil.
can turn it down, apparently.
Yeah, please, Phil.
Who
Correct,
said,
Howard.
Who said I can't manipulate it?
Okay, listen very carefully, Phil. I'm very clear. Howard just said a couple of minutes ago, you can't manipulate gravity. And then earlier, he said, you can't turn it on and you can't turn it off. So, Phil, please educate.
Well,
Howard.
I'm not the. I don't know. I'm not Howard. I'm a physicist.
No, let him talk. I want to know.
He can't talk. He can't talk. He's not going to be able to isolate his cause. Everything else
Yes,
he can
I can.
isolate. Okay, then
I can
tell us
change-
how.
I
Tell
can
us how.
change how gravity. I can change the effect.
Don't
of gravity.
tell us what you can do. Tell us and show us how you can do it.
Easily. You go
No,
up. You go further. You further away from the ground. Gravity changes.
You know what? I think you do
How do
when
you
you
know?
put something in a vacuum chamber and you watch it drop. I think you are isolating the cause of why it falls. The only thing that's in that fucking vacuum chamber is the object.
And the force that's created, causing it to fall to the ground.
Nope, we don't see any force. We see an object in a vacuum
Why does it
that
fall
falls.
to the ground,
We
Brandon?
don't see
Why
a
does it fall
force.
to the ground?
Because it's heavy.
It's
Not only
fine.
that,
It's
why does it
unsupported.
accelerate to the ground?
Yes, there's a
But here's
downward
the
bias.
thing,
We
it
can
is-
talk about
it is
that, but
supported.
you're not measuring any force.
Yes.
It
Why
is
does
supported.
it accelerate
The
to the ground?
only thing that you're measuring is the object.
Why does
Incoherent,
it accelerate to the ground?
I don't know, and
incoherent
neither do you.
dialectic acceleration.
Why does it accelerate to the ground?
I don't know, and neither do you.
Incoherent
do.
dialectric
Of
acceleration.
course I know why it accelerates to the ground.
Well, here's why it accelerates.
Travis is
It's
right.
because it's unsupported and it's more dense than the medium that it's in. That's why it
Why does it
accelerates. And
accelerate?
in order to move, something has to accelerate. So if something is in a vacuum, in the air, unsupported, it has to fall down and it has to accelerate because when it moves, it accelerates. You can't move without accelerating.
Got that. By Jove, you brilliant, you absolute genius.
Well,
Thank you.
It takes
Thank
the
you.
easiest path to its density level, which is straight down.
Awesome.
Yeah, and gravity wasn't mentioned once, Phil.
And by the way, when you have a look at density, think about what density is. Okay? It's mass over volume, all right? Nothing to do with acceleration and nothing to do with a vector down.
Or gravity.
Relative.
Yeah, funny about that.
Well, no, of course it's not gravity. Density is not gravity.
So we don't need gravity.
Density,
Yeah, density
by
has-
itself is nothing but a density by itself is nothing but a scale or whatever. It's but
Yeah.
relative
You
density.
need the disequilibrium. You need two different things at two different densities, like the medium and the thing.
What about things falling in a
If-
vacuum?
Listen.
We don't live in a
Paige,
vacuum, Howard. Who gives a
Paige.
fuck what happens in a vacuum?
Paige,
Things
what
still
happens
fall
in
in
a
a vacuum.
vacuum? What happens in a
So
vacuum
what?
means
It's not
eliminate the
analogous
other
to where
forces.
we live.
No,
If
Paige.
both are
The vacuum
density.
eliminates the other forces. That's the
Hold tight.
issue.
Well, then those
Sorry.
forces are there when you're on the earth, where we are, where we live, not in a vacuum.
Yeah, we can create a vacuum and watch things fall.
Does
Why
everything
would
fall in
you?
a
We
vacuum?
don't
Sorry.
live in a
Free fall.
vacuum.
You're taking it out of
Quick,
equilibrium.
Does everything fall in a vacuum?
Of course.
Right,
yeah,
awesome. So, sorry, just 2 seconds. I've got a bowling ball and I've got a container of gas at the top of a vacuum chamber. Now, when I drop the bowling ball, release it when I press the button, the bowling ball goes down. When I open the container of the gas disperses in all directions and presses on the insides of the walls of the container, including upwards. So, no.
Boom!
It
What does that mean?
depends on which gas you're talking about, of course, doesn't it?
Hold tight.
shouldn't
Any
matter.
gas. Sorry, 2 seconds. So any gas in the vacuous space, I
No.
open the container. Hold tight. Let me finish, please. So I've got a vacuous space, and inside that, I've got a container of gas. When I open the container of this gas, it disperses in all directions and fills the vacuous space. So it's not a vacuum
Depends
anymore. It's a
on the
container
gas.
of gas. Depends
they
on the
go
gas.
On the gas.
It'll be more dense at the bottom.
It depends on which gas you're talking about.
So any container of any gas will contain the gas, won't it?
No,
So
you're
Harry
wrong.
says the balloon will be pear-shaped.
You're wrong.
I'm wrong.
If you put if
So
you, if
when
you put
I
some if you put some let's call a tetrabromoethane or tetrabromo in that chamber, the gas will go to the bottom just like the bowling ball does.
Yeah,
So a
hit the
man-made
fluoride,
gas.
but if it was the only gas, it would go everywhere. He's right. Even the sulfur hexafluoride would distribute equally if with nothing else to relate.
Yeah, over time.
No, it wouldn't.
No, it won't.
You-
It's
No,
got
the
nothing
only
to do
reason it
with the
sinks is
amount of-
because of its relativity to the air. The only reason
No,
sulfur
it's got
hexafluoride
to do
goes
with the
down
energy.
is because it's denser than the air
No,
around us. If there's no air in the evacuated container,
you're
it
wrong.
would disperse. He's right.
You can,
No,
Well,
it'll go
that
down.
would be a good experiment, though. That would be a good experiment.
It's a man-made gas.
You're
It's
wrong.
a man-made thing.
So what?
wrong.
Tell them to use
The
something that is in our atmosphere, something that is actually what we're dealing with. You know,
Good. Carbon
oxygen.
dioxide will do it.
Right.
Do what?
So
Carbon
What I'm trying
dioxide
to-
will also sink.
Sink
Will fall.
where?
All
Sink
of it.
fall where?
All of
Carbon
it will.
dioxide- you
Any
can
gas
pour- you can
accumulate at
pour
the
carbon
bottom.
dioxide just like you can pour a liquid.
Into what?
Anything you like.
a vacuum.
A container?
Sorry.
Whatever.
So
What would
every
happen if I
sorry,
just poured it out?
I've
Yes,
got
you
a
can pour it
vacuum.
out.
Sorry, I've regularly got to
Hang
do
on.
this. So I-
No, hold on. I'm talking to Phil. If I pour that gas out, just pour it out on the ground,
Yep.
what's going to happen?
Well, it'll spread around the ground just like it would if it was water.
So you need a container.
If you want to
Okay.
hold it together, of course you do. You
Yeah.
don't
So
need
we
a-
want gases held together here on Earth. I hope you
That's a
soundbite
good
that
one.
one.
You don't need a lid. You don't need a lid.
Well, what the hell's the
Phil,
sound
stop.
bite?
If there's no lid, the
you
gases...
like a
It's
hyena
not
going
a
into your
gas.
brain
It's
cells.
not a
Stop
gas,
laughing.
Phil. Of course
Phil.
you don't need a
I
lid.
wouldn't
It's not a
laugh if I
gas,
was
Hang on,
Phil.
Travis.
if I had your mentality.
Phil, your mic has gotten low
Phil.
for some reason.
Any gas in a container with an opening anywhere on that container, like a hole in your car tire, it will eventually dissipate. That's
It
what
depends
gas
on the temperature,
does.
Paige. It depends on the energy,
Phil,
Paige.
can
Do
you let me
understand
finish?
energy's got to... No, Paige. Do you understand that
Oh
energy's
my
got
God,
something
no.
to do with
You're
it?
not going to let me finish. Wow.
What
No,
else have
because
you
you're
got?
talking nonsense, Paige.
Yeah.
Why don't
What,
you
it's
just stop and
nonsense that
learn
if you put
something
gas
for a minute?
into an open container or into a tire with a hole in it, that it will eventually dissipate? That's
That's
nonsense,
not
is
the
it?
same thing. That's not the
Depends
same
on
thing.
the
Excuse
temperature.
me, Phil.
It's not the
Is it
same thing.
nonsense that a tire will deflate if you've got a hole in it?
It's not the same
If
thing.
you put
Stop!
carbon
Howard.
dioxide in a container, if you pour some carbon dioxide in a container, if it's cold enough and you keep it like that, it will remain dense at the bottom.
Okay.
Do you understand?
That temperature that you've got is that what the temperature of the Earth is?
It
Everywhere,
doesn't
all
matter,
the time?
Paige. I'm trying to demonstrate
It
to you
doesn't
that
matter.
gas
You
will
just said
fall.
the temperature matters to whether it moves or not.
Well, of
Now you're
course
saying
it
it
does.
doesn't matter?
I didn't
That's
say
what
it didn't.
temperature
I didn't
is.
say it doesn't matter whether it moves.
You did. You said, I said, is the Earth that temperature to keep the gases there? You said it doesn't matter.
That's not what we're measuring, Paige. We're measuring
Oh,
gravitational
Phil.
field.
Really? You're making me so cross.
Well, I'm sorry,
You know
Paige,
damn well that if a tire has a hole in it, eventually,
Paige, I
over
too would be
time, those
cross if I
gases
knew as
will
little as you do.
dissipate.
Not the same thing.
It is the same thing. It's the same substance. Gas pressure. My
A tire
God,
under
you
pressure.
guys.
A tire under pressure in a container of gas sitting on a table is not.
Hey guys, let me read this super chat here. There's actually a question in here, and maybe Phil or Howard can take a shot at answering it. It's from Brian's Logic. Shout out Brian's Logic for €549. 2 balloons of equal size, one filled with lead and the other filled with helium. If both dropped in a vacuum chamber, which will hit the floor first?
They'll hit the floor at the same time.
Yeah.
Did you just say yeah, Howard, just to agree with him, or did you actually know?
In a vacuum, they will fall at the same rate.
Yeah, but I'm asking you, did you know that before Phil said yes and you just agreed with him, or did you just agree because you heard him say yes?
No, I agree because
Chat, 7 different elements in a vacuum tube falling at different rates. Y'all give up on that crap.
Yeah, because I was just going to say, have you seen those demonstrations where that's not happening, Howard?
Peter and Pete are
like
charlatans.
You really have got to stop. Howard, you have got to stop just agreeing with these people like Rumpus and Phil and George.
I'm not agreeing.
You do. You yes after everything they say. Even when they say something wrong, you'll say yes.
Okay, wait, hold on real quick. Hold on real quick, Howard. You just said something
wrong. I do not agree with.
Hold on. Paige, when you were talking about seeing an observation with objects being dropped in a vacuum, were you referring to Pete and Peter?
That's Brian is doing that.
Okay.
Yeah, and their second.
Hold on.
Yeah, that's the
Hold
one I'm
on,
talking
Brian.
about,
Stop. Listen. Stop. Okay, hold on. Paige said, she said to Howard, Howard, have you ever seen the demonstration where two objects are dropped in a vacuum and they don't fall at the same rate? And Howard said, I don't watch Peter and Pete. So my fucking question still remains. Paige, were you talking about Peter and Pete?
I don't think so. I know them, and
that's fine.
I'm sure
that's all fine. That's all fine. But Howard, your
but if
rebuttal.
they've got one,
hold
then
on,
great.
hold on. Your rebuttal, Howard, is a non sequitur because she didn't reference Peter and Pete. She didn't reference Peter and Pete.
Brian was talking over her, talking about the video he posted in chat, and it is Peter and Pete video.
Okay.
Yeah, but it's not their video. They mirrored it, and they
Listen,
did 2 of them, dude. This has 7 different elements in vacuum tubes, following every one of them at different rates in slow motion. And Peter and Pete didn't do it. It was done by a lab.
That's the one I've seen. Yeah, they all fall at different, and they're metals, and they've got them set up.
Not in a vacuum.
Yeah, so the answer then, Howard, is no, Paige. I have not seen that demonstrated, Paige.
I have seen videos where they're showing stuff falling at different rates, supposedly in a vacuum, but they were debunked.
Impossible.
I can't beat. Yeah. They were debunked.
Of course, they'd be debunked.
Of course, they'd be debunked.
Well, it wouldn't matter anyways.
What about the feather in the bowling ball?
We don't live in a vacuum. We don't live in a vacuum, guys. There's no reason.
I don't even understand the point in arguing about what happens in a vacuum when.
Well, I want somebody to. When these are, hold on, let me say something real quick. I'll be quick and I'll mute. Let me just say this. First of all, you take the very thing that keeps you alive out of this man-made device. Unnatural, right? Unnatural. I want you to stand in it when these experiments are being done. No protection, just you. Stand right in it. You're not going to do that. You're not you're not going to do it. Well, it's the only way you can get your theory of gravity to work or to even be arguable, I guess. But
no,
it's only done in a vacuum chamber, and you're just claiming what you want to be the outcome. So there's no scientific evidence, right? You've never observed gravity. You don't observe it.
Yes, we do.
You can't
drop anything and you'll observe gravity.
But this is like going underwater, doing something underwater, and then saying that's going to be the same as when I do this out in the air. It won't be. Like if you let go of a leaf in water, it'll float. You let go of a leaf in the air, it'll fall. So if you're doing an experiment in water and saying this experiment shows what happens in air, you're full of shit.
Right.
Just like if you're in a vacuum and saying it's analogous, you're full of shit.
We
No,
we don't say
nobody.
what happens in the vacuum happens in
That's
the
why,
air.
but that's why I said
Exactly.
earlier I would give you the downward bias. I would give you that. Like I'll give you the downward bias.
Thank you very much.
But
You
you're
don't need
just
to give it to me.
attributing.
It exists.
Yeah, but you don't know
Well,
what the
just for the
reason
sake of
for it is,
argument.
Phil.
For the sake of argument, I did sound egotistical. I wasn't trying to. So I'll give you the downward bias in the vacuum. You have this thing of gravity where it's only observed. It's not even observed in the vacuum, right? You're taking every lifeblood out of the vacuum. You can't live in that environment.
You're just changing the medium
And then
anyway.
you're claiming
The
it to be
medium is all you're
something.
changing.
Now, can I say
Yeah,
something?
Changing it to
you're
something
changing the
that's not
medium. But
analogous
let me
at
get
all.
back to my point. Let me get back to my point real quick because I didn't want to lose the downward bias that I said we're just going to give you that in for the vacuum experience, right? You're just saying that it's something outside the vacuum that you're claiming gravity, but outside that vacuum, we don't experience any of it. You
do.
don't experience any of it. No, you don't.
Yes, you do. But you also experience.
Hold on. Okay, does the helium balloon in a vacuum chamber go up?
No.
Obviously, you took the gases out to get it.
Answer, Professor Phil.
No, helium balloon in a in a vacuum chamber will fall.
It will fall.
Of course.
If a balloon filled with helium.
Of course.
Even though you took the gas out to get it.
The
It
helium
will
don't
fall.
fall. The balloon falls. The helium goes in all directions.
That's what I'm saying. That's where my next point was. Because if you popped it, you're filling the vacuum back up.
Why do
was
you
the
think
point
that
earlier
happens?
from Jedi.
Why do you think
And the
that
gas
happens?
doesn't fall. It doesn't fall because
It-
that's
why-
what you
why
took
do you
out to
think-
get it. That's
Why
what
do
you took
think
out.
that happens? Why do you
But
think
Phil,
that
but why
happens?
didn't you answer earlier? Why isn't that gas being attracted to that bowling ball like he was explaining as well earlier? Why
It
isn't this
is.
gas being
I
attracted to
told
mass?
you
No,
it
it's not.
depends. I told
Okay.
you it depends on which gas it is because the amount of energy matters.
Oxygen. The gas
No,
we're
you
breathing.
change the medium, you change the result. The helium balloon falls in a vacuum, right? But
Of
rises
course.
in reality because
Do
you
you know
took
why
the
it rises?
gas. You took. Hold on.
Do
Because
you
if
know
you
why?
put, hold
So
on, let me
why is
finish.
my
Let
tyre
me
not
finish.
analogous, but your
If you
vacuum
put the
is?
gas back in the chamber, it's no longer a vacuum, right? So gas on Earth, it doesn't fall.
It does.
Hold on again. The balloon
No, it
falls. The
doesn't.
helium goes in all directions.
Goes in
You got to
all
have a
Balloon
man-made
falls.
device to do any of
listen.
this.
All right, guys. I don't think we're gonna get to the bottom of that tonight, so I'm gonna cut it short. I got a hamburger waiting for me, and I am getting very hungry. Hope you enjoyed. Thank you for watching and listening, and we'll see you tomorrow night. We'll probably continue to go through those 100 proofs. That got a good conversation going, and it's pretty interesting to read what they thought back in the 1880s. Try to take yourself back and put yourself in their frame of view. So good idea, Chrissy. Much appreciated. Yeah, anyway, have a good night, guys. Thanks again. Thanks to my channel members and everyone who supports the show. Thanks to the mods. Have a good night. We will see you tomorrow. Bye.